to the Frontier Research Session. My name is Igor Babushkin. Formerly, I was a co-founder of XAI. Now I'm the CEO of a new AI company called River AI. I'm going to be moderating the session. We've got some really amazing speakers for you today. Very excited to get started with the talks. Before we get started, just wanted to kind of set the scene a little bit. So this year, we've seen some incredible progress in terms of agentic AI, especially around coding agents. So they've really taken the world by storm. A lot of the software engineers I know, they swear by them. They tell me I haven't written a line of code in 6 months, and it's still still spreading across the world. There's also a lot of economic impact with companies generating tremendous amounts of revenue from serving these powerful coding agents. And it really, as a researcher, it really kind of creates this question: what will come next? Are coding agents the end? Probably not. There are going to be some new developments, even more capable agents. And there are multiple possible directions. We're going to be exploring a few of these today with our speakers. So for the first presentation, we've got Richard Socher, who's going to talk about his new AI company, Recursive Superintelligence. So to give you a little bit of introduction, Richard is somebody that I'm sure many of you are familiar with. He's widely credited with pioneering the use of neural networks in language learning in general, including the use of word vectors, contextual vectors. Maybe you've heard of recursive neural nets as well. And he's one of the highest cited researchers in NLP today. He's also a very, very prolific entrepreneur, having founded MetaMind, then U.com, and now he's come out of stealth with his latest startup, Recursive Superintelligence. He's raised $650 million to build AI that masters research and ultimately is capable of improving itself further and further. So welcome, Richard Socher.
Hello, hello. Really excited to be here in Berkeley. And yeah, we'll talk to you a little bit today about what I feel like is my personal version of going to Mars, and that is the Eureka machine. It's the ultimate invention for humanity to automate all future inventions. And to get there and to motivate that, I think we have to get to recursive self-improving superintelligence too along the way. Now, one of the processes we're the most inspired by, which is still to some degree underexplored in the AI community broadly, is that of open-ended evolution. And we'll walk in a very quick succession from billions of years of biology to thousands of years of science to the now weeks-long craziness that is AI. If we start with biological evolution, we can see that it is one of the most inspiring sort of open-ended processes that we're aware of. And indeed, when you zoom in, you realize that only at the very end of this very, very long billion-plus-year process, it led to us, right? Inventing our eyes and so on, developing those. And so we want to basically be able to replicate this, but with technology. And if you think about technological evolution, it also was one of the major contributing factors to allowing humanity to thrive, not just in terms of GDP, but also just in terms of sustaining and allowing people to flourish on this planet. And it mostly came, again, from technology. Basic things like hunting and farming to Enlightenment, the Industrial Revolution, and so on. Now, let's zoom into just the last few hundred years and maybe a few thousand years. Even there has been this incredible move that allowed more people to live on this planet because of technology. And what's interesting is that when you zoom out and you think about this, I believe actually that the only perpetual source of growth is technology, as Mark Andreessen said. And in fact, we can go even further and say that there are no material problems that cannot be solved with even more technology. Material, not psychological problems, and political and so on. It's a different beast. But I believe that we need to be able to really accelerate this, and not doing it is actually a bigger danger to not allowing as many people to flourish. And what's really exciting is that in many ways our generation was too late to explore the Earth, too early to explore the stars, but we were right on time to build superintelligence. And unlike previous technological jumps, this will actually happen, I think, a lot faster because of technologies like recursive self-improving superintelligence. And when you look at some examples of technologies that have moved very quickly, you can actually see that within one lifetime, like in early 1903 or so, no human had ever sustained powered flight. And 60 years later, we landed on the moon. Right? So within 60 years, within one lifetime, humanity had this massive jump. And now a lot of acceleration technology is in software, so it's even faster. And so I think our generation will go from no human having been able to interact with an intelligence, an artificial intelligence that's smarter than it, to one that is likely smarter on almost every task than a human. I think that's the goal here. And in the interest of time, I'll kind of switch or move through these fairly quickly. But when you think about technology, there's obviously deep theories and connections to science and theory of it. And we think about science. But long story short, we basically can fairly clearly say that more science will lead to more technology, which will lead to more growth, which will lead to more human flourishing. And that then begs the question, well, how do we accelerate scientific discovery? That is the number one goal for us. And there's a lot of good reasons of why we should do it to mostly help help humanity solve a lot of different problems. Now, this is something I've been thinking about for quite some time. I just finished a book. It'll come out in September called The Eureka Machine. And I believe that AI is the actual unlock for this. And when you think about this full Eureka Machine in all of its glory, there will be basically 4 different pillars. Those pillars are, first, the existing knowledge that we have with humanity, mostly now incorporated by LLMs. A lot of people struggle sometimes with sort of legality and the copyrights and companies infusing all the knowledge from the web into an LLM. But now that they're open source, they're becoming more and more a resource for humanity, just like the internet had been. So I think that is the first pillar, existing knowledge that's publicly available. The second pillar is going to have to be grounding it in a lot of scientific measurement data. Just human eyes are very limited. Human senses are very limited. Obviously, AI, in terms of the upper bound of perceptual intelligence, could be much, much bigger, and that is unlocked largely through scientific measurements. Now, not everything has been measured, and hence we need a third pillar, which will be simulations. Everything you can simulate, anything you can essentially verify, AI will obviously solve. Like, I personally have never been that surprised that we can beat chess and Go and all these other games, because you can essentially simulate it, verify it, and hence create unlimited amounts of training data. And then, of course, there will be some things that we cannot yet simulate either, and we eventually have to go and actually do robotic process automation and really automate physical labs. And then on top of these 4 pillars, you essentially have an agent swarm. And that is what that agent swarm, ideally, before you ask it to do physical experiments and so on, you want to have it have the equivalent of like 5,000 different PhDs. And so that is essentially our goal at Recursive, where we want to automate science. And which better science to start than the science of AI itself, right? And that's where you get recursive self-improvement, where in a very scientific way, you essentially allow the AI to build a certain sense of self-awareness of its own shortcomings based on the entire process from pre-training to harnesses and everything in between. And I think that is now uniquely possible, especially actually this year, because AI is code and AI can code, right? And so now that we have been able to accomplish that and accomplish it also for longer and longer time horizons, that allows us to really let AI work on itself. And when you think about the process of science, but also AI research, it's essentially 3 major steps. It's the ideation, implementation, and validation of ideas. And then it just is now the question, how well can you ideate? How many truly novel ideas can you come up with? Obviously, now we can implement them better and better. And I think the validation still can take a lot of time. And one thing that we're seeing in a lot of different places now is auto research, which is an incredibly useful milestone, a stepping stone towards true recursive self-improvement, where you ask one AI to improve some other system. right? That's not true recursive self-improvement, it's just auto-research. But when we took our RSI system and actually applied it to 3 different benchmarks that thousands of people have worked on, often together with their agents and their own like sort of human curiosity, we could see that this AI actually outperformed years of prior research across 3 different benchmarks. One is called NanoChat, very popular auto research benchmark, where we're able to reduce the bits per byte significantly within less than 2 days of like asking our system to research this problem. NanoGPT Speedrun is also very useful, trying to create faster and faster training algorithms. And then SolExecBench is a benchmark from NVIDIA that basically evaluates kernels, CUDA kernels, the interface between GPUs and actual AI code. And there too, we made a significant jump. And it's interesting because it's not just like tuning hyperparameters. It makes some truly useful inventions, like incorporating hash tables into transformers and other things, like coming up with new types of momentum and so on. And you know, speed is very important. If you want to reduce the intelligence per dollar of your foundational models, then you know that becomes crucial. And CUDA kernels are a big part of all of these types of algorithms and running them efficiently in very large data centers. And you can imagine that if you spend billions and billions of dollars on these data centers, and then you could improve them by 5 or 10% efficiency, it's a very significant you know, end result for companies. And so as we look into the arc, I think, of human history, and it sounds a little bit grandiose, but I do really believe that we're living like in this moment in time right now, then I think recursive self-improving superintelligence that automates this kind of scientific discovery is another step function in a sequence of these cumulative S-curves. And in many ways, we have only started scratching the surface in AI. I actually tried to define AI in its full sort of complexity, and there is no really good definition. I think ultimately it boils down to 3 principal components, which is essentially prediction, which is mathematically equivalent to compression, multiplied with actions, multiplied with goals. And from these 3 principal components, you can eventually essentially evaluate these and study these 10 different spaces of intelligence. And just to give you a sense of how far away we are, and then I'll end the talk. The visual intelligence, which is the simplest one to sort of think through, is incredibly early, right? We often think in computer vision in terms of just the electromagnetic frequency spectrum of the human eyes. Human eyes are not that amazing, right? Mantis shrimp have more amazing eyes. But you could, if you think about the upper bounds of intelligence and how much further AI can go, you can realize that it couldn't just be binocular vision. You can have millions and trillions of sensors. Eventually, you can think about the speed of light cone around all of these sensors and how far apart they could be to still be able to communicate to one central intelligence. And you can realize that they can see all the way down to the quantum level of uncertainty there, and that's an upper bound. And they can go all the way up to gravitational waves, and then merge all of that, think through many more different layers of abstractions of types of objects and so on. So just to give you a sense, like when people think, oh, AI is going to not go that much further, we're literally astronomically far away from the upper bounds across many of the different spaces of intelligence. And that, I think, makes it very exciting and still a very useful area to research. So yeah, if you want to work on those kinds of things, let us know. Thank you. Should I sit here or go back? See you soon.
Thank you, Richard. Next up, we have Ed Chi, who's the VP of Research at Google DeepMind, where he leads machine learning research on LLM applications such as Lambda. He was involved in the launch of Bard and Gemini, and now he's working on universal assistant agents like Project Astra. He's a co-author of the famous chain of thought prompting work, which today is one of the core ideas that power all of these amazing agents that we're using every day. Before Google, he was a principal scientist at Xerox PARC, and he's an ACM fellow and a member of the SIG CHI Academy. A few people have shipped agents to more users than Ed, so please welcome Ed Chi.
All right. Hi, everyone. Good afternoon. Last night, I was at the reception, and someone told me that based upon last year's talk, they made a lot of money in the stock market. So I don't know if I can make that promise today, but to be honest, I have a confession to make. I'm actually a very slow learner, and I've always felt like I have imposter syndrome. How many of you have imposter syndrome? Yeah, me too. So, you know, one of the things I wanted to talk about is that it took me a long time to figure out what were really the key ideas that really matter. Because as a scientist, I really cared about was not writing the next paper, but what the next big idea is. And in reality, even though I've published more than 200 papers, there's only probably 10 that I feel like I'm even proud of. And so I wanted to tell you in retrospect what I feel like are 3 very important ideas from the first 2 decades of my graduate research career. And they come from the area of information retrieval. And these are ideas that many of you have already heard about, so I'm not going to go into detail, obviously. But the first one, let's just pause and think about the first great invention of humankind, in my opinion, which was the library. And the library actually is built upon the idea of indexing. And so that was the very first big idea from the 90s, where we used MapReduce to build very large search engines. But it needed a second idea, which was vector space models. And only a few years ago, the Word2Vec paper was voted as the 10th year Test of Time Award for Word2Vec. And it was based upon the idea of vector space models using neural networks to compute relationship between words so that we can have better understanding of semantics and what words really mean. And those were already 2 ideas, and I'm going to tell you the first major mistake I made as a slow thinker and a slow learner. In 1992, my PhD advisor, John Riedel, came to me and said, what if we use those vector space models and applied them to user item matrices instead of document turn matrices? This was the birth of recommendation systems. And I told him it was a dumb idea. Okay? And the reality was that once we got huge supercomputers, we were able to do one thing much, much better. As a result, that made search and recommendation systems so much better. And that was sorting. The reality is that what we're doing is ranking. Right? So if you think about the fact that next token prediction is nothing but sorting to the next most likely word you're going to say or to communicate, everything has been about sorting. So the third idea from the period, the latter part of 2010 to 2015, is deep neural networks. And at Google, actually, we made very good use of this, as you can imagine. But in 1992, when I was a graduate student, this was a supercomputer. It had 2.6 gigaflops of computation. The phone in my pocket right now has 1,690 gigaflops. Okay, almost 1,000 times more computation. And all this powers all the applications that's in your pocket right now. We're all walking around with like 1,000 supercomputers in our pocket. Luckily, it's not burning a hole in your pocket, right? And so if you think about the whole internet ecosystem, this is what we're talking about. The whole thing is still based upon sorting and ranking and recommendation systems and search. So those were the 3 ideas from the first 2 decades of my research career. In my opinion, that really matters. Indexing, vector space models, and deep learning. Now, the interesting thing is that deep learning is the real thing that connected to our present time. There were 3 ideas from 2015 to 2025, and I noticed Vincent is here, and you'll hopefully agree with me, that really mattered from those 10 years of time period. How many of you have seen this figure? Yeah, everyone's seen them. Have you ever read it, the paper? Okay. The very first sentence of the abstract says this: The dominant sequence transduction models are based upon complex recurrent neural networks that include an encoder and decoder. I'll admit to you that the first time I read this paper, I have no clue what that meant. How many of you still don't know what that means? Yeah, that's what I thought. Almost at least 50% of the people raised their hand. What is sequential transduction? What the F does that even mean? Right. It turns out that the word transduction means the transformation from one energy wave into another energy wave. As an example, you're experiencing transduction right now. A microphone that I'm wearing right now is a transducer that transforms sound wave into electrical wave. And there are speakers all around this hall that turns those electrical waves back into sound. That's how you're able to hear me. In fact, your ear is a transducer. It's listening to what I'm saying, and that sound is going into your ear, which has a membrane, and that membrane is vibrating, and it's connected to a neuron, and those neurons are transmitting information into your brain. That's how we're able to communicate. That's how you're able to understand what I'm saying. So the major first idea in 2014 or so was actually the idea of using sequential transduction and marry it with neural networks. It was an incredible idea, right? And so it's very important that you understand we're not just doing sequential transduction in the ether. It was based upon a cognitive understanding of how our brain worked. That's how we're able to communicate. That's how we're able to communicate with our computers at this point. The amazing thing is that this model, this new universal computational model, is able to do convergence. It's able to take in multimodality data. It's able to understand all kinds of different languages all at the same time. The second big idea from that 10-year period came from a basic question that Danny Zhao and I were asking in Google Brain, which was, can we teach machines the way we teach our children? It turns out there was one dominant way in which we were doing it wrong. How were we doing it wrong? When you teach your kids, I hope every time they get it wrong, you don't just hit them. But that was the way that we were teaching our machines. Danny and I thought, maybe we should give them an explanation why they were wrong. That came out with the idea of chain of thought, right? Give them an explanation. This is how you do it. And then have them follow the recipe for how to solve problems. This is known as top-down processing. These days, in our industry, in my personal opinion, we actually have way too much bottom-up processing, particularly using RL, when in fact we should be teaching machines the way that we teach kids with more top-down processing. Give them explanations. So if you think about it, how are we able to distill one model into another? It's all because of chain of thought, the reasoning traces. So the emergence of this idea of going from next token prediction that was enabled by sequential transduction into next idea prediction using chain of thought was the key move that started the whole reasoning field. Now, so in retrospect, I wish we had not called it large language models. Rather, we should have been calling them large reasoning models, because what we really care about is their ability to reason. So there were three ideas, therefore, in 2015 to 2025 that really matter. The first one, sequential transduction. The second one, next idea prediction with chain of thought. The third one is post-training. And there are plenty of talks here on this stage talking to you about how post-training is done and all the latest advances that's going on there. Now, what are the emergent ideas in the next 10 years from 2025 to 2035, let's say? Well, what if all of this ecosystem starts to change, for example? If didn't realize a single V8 TPU chip now is 4.7 times more computation than the Cray YMP that I showed you at the beginning of the talk. That's definitely going to burn a hole in your pocket. And what is it enabling? Let's take a look at a short video.
I get a gift from my friend, and this is everything she's been reading. How would you describe her taste in books?
Based on these titles, your friend seems to enjoy a mix of history, biography, and perhaps a touch of political or social commentary.
I picked some of these out. Any idea which one she'd like the most?
Consider Half of a Yellow Sun for its exploration of complex social and political issues within a historical setting, aligning with her interest in narratives that offer insight into significant periods.
Now, that is not just sorting and ranking anymore, is it? Okay. That is where personal assistance is going. Last year, when I was on stage here, I showed this slide. Okay, that was more than a year ago. Now everybody is talking about agents. The ideas were already there. The next ideas of the next decade is already happening. And Richard just talked about self-improvement, for example. There have been other speakers that talk about multimodality, tool use, multi-step complex reasoning. My main work at Google at this point is just focused around reasoning and planning, because that is where the future is. Thank you very much.
Thank you, Ed. Our third speaker goes by Dosh. He led materials science and chemistry at Google Brain and Google DeepMind, where he led the work behind GNOME, which discovered over 2 million new crystals. Last year, he co-founded Periodic Labs with Liam Feddes, building AI research agents that are paired with autonomous labs that run experiments end-to-end, with high-temperature superconductivity as one of the North Stars that they're pursuing. So that would be amazing. As a physicist, I would love if they achieve that goal. If you want to know what happens when the reward signal comes from a furnace instead of coming from a unit test, this is really one to pay attention to, so please welcome Dosh.
Hello, everyone. My name is Doğuş Çubuk. I'm a co-CEO and co-founder of Periodic Labs. And we combine simulations, experiments, and LLMs try to accelerate physical R&D. So for the next few minutes, I want to talk about whether AGI, either today's AI capability or the future AI capability, could just zero-shot the next big scientific breakthrough. And I say it has to be zero-shot because the breakthrough, by definition, can't be in the training set. So it must be something that's different than what's been done before, so it has to be done without previous demonstration for that breakthrough. You know, another way of thinking about this is, can thinkism ever be enough for advancing physics? So thinkism is this idea that you lock yourself in a room and you have all the textbooks, all the previous experiments, papers, patents ever been done in the field. And then if you think really hard, whether you're a human or AGI or AI, a bunch of agents, can you advance physics? And I will argue for the next few minutes the answer is no, because the universe is too complex for any intelligence, whether it's humans or machines, to think their way into the scientific advance. So what's the alternative? The alternative is what we've done for centuries, which is you iterate with the universe. You have a hypothesis, you try it. It usually doesn't work on the first one, but you learn from your failure, and then you keep trying. So one very interesting history to the study for this topic is the history of superconductivity. You know, if you study history of superconductivity, you learn a lot about humans, science, scientists, academic publishing, archive, etc. But today, I'll just focus on a few things. So the superconductivity for the first time was discovered back in 1911, and it was not discovered because an incredible human just thought really hard and then said, okay, if you take mercury and figure out how to lower the temperature, electrons will feel an attractive force through phonons. No, what happened is Annes's lab, this lab led by Kamerlingh Annes, for the first time created a capability that can lower the temperature below any temperature recorded before, and it was around 4 Kelvin. They got it down to 1.8, but turns out for some metal like mercury, if you can get it to 4 Kelvin, it will superconduct. So it was actually a side project of the main effort, which was to liquefy helium. And a few years later, Anes got a Nobel Prize. But very important to note, Nobel Prize was not given to superconductor discovery. It was given to the fact that he could liquefy helium. And if you look at the rest of the history, it's full of examples like this, where the big innovation wasn't done fully intentionally, and it wasn't done by thinking really hard, but it was done by trying a bunch of things and iterating intelligently with the universe. So another really good example is around 1958, John Bardeen and collaborators figured out the theory of BCS superconductivity. So this is conventional superconductivity, and it's great, right? Now the humans understand how superconductivity works. We can use that understanding to discover lots of other superconductors. But that's not really what happened. So if you follow this curve from 1958 to around 2000, there's been really major advances into conventional superconductivity. The biggest one, the SODA in deep learning language, is magnesium diboride, MgB2. But if you look at how that was discovered, it was not discovered by humans taking the theory, thinking really hard, and making the material. It was more like they were trying tens of thousands of materials, and that particular one happened to be a really good BCS superconductor. And of course, the other really good example is the cuprates. Around 1986, Alex Mueller and collaborator were able to find the first high-temperature superconductor, the unconventional one. But if you look at his Nobel Prize speech, you realize he was actually trying to find a conventional superconductor, because he didn't even know what an unconventional superconductor would be. So this is just for superconductors, but if you look at other aspects of material science, chemistry, solid-state physics, so I'm not talking about math and theoretical computer science. I think that's a different regime. But if you look at complex systems like physics, chemistry, material science, you realize that most things were found by either accident or a bunch of trial and error. Okay, so if this is the case, what does this mean for agents and LLMs? So I think we're fine. We just have to figure out how to use agents in the scientific method that we've been using for hundreds of years. So a very simple way of looking at it, right? We have some observations, we come up with an hypothesis, we try the hypothesis through an experiment, and then we look at the result. It will probably not work very well in the first time, but we understand why it failed, and we try again. So this is the typical scientific method, but how we can improve this with LLMs and agents and machine learning is we can insert it in a bunch of places. So one example I can give is the simulation part in the very middle. So the simulations are already completely revolutionized by machine learning. So today we use force fields which approximate quantum mechanics of the ground state. And I can't even if there's another AI winter, I can't imagine ever not using machine learning anymore for force fields. Another example is, of course, AlphaFold. Now we figured out how to do protein folding way better than before, thanks to machine learning. But force fields, AlphaFold, these are all tools, right? They don't actually give us the next big drug or the next big superconductor, but they're very useful tools. And there are other tools, of course, such as characterization, which helps us look at the experimental data and figure out what happened. It's very technical, but AI can really automate and scale that up. And at Berkeley here, there's been some frontier work showing how you can use robotic arms to try a bunch of things in the lab for synthesizing powders, and characterization is the obvious thing you can improve with AI. Another example is literature search, going through all the papers and figuring out what other ideas to try. And of course, DOE, design of experiment, where based on all the experiments you've seen so far, what should be the next experiment? So in our company and outside our company, AI is making a huge impact on all of these parts. And of course, it's not this clean. It's actually much more complicated. It's a spaghetti plot where everything interacts with each other. But you can easily see how the whole scientific method can accelerate if we put AI in it intentionally and carefully. So my last slide here, I just want to say, in my opinion and in our company's opinion, this universe is too complex for thinkism alone to innovate. So instead of looking at the current LLM progress and getting discouraged, especially if you're a science student, you should think the opposite. It's actually a really exciting time to do science. And what I would recommend is to fully focus on understanding the fundamentals. If you're a physicist, study the theory of superconductivity, study solid-state chemistry. If you're a biologist, study what's important in biology, I don't know. And really understand the scientific fundamentals, experimentation, because you realize that a lot of progress happened when people came up with new experimental methods, new techniques, new measurement tools, and you can contribute to all of these, and as you create new experimentation methods, new tools, then AI will benefit from it, because AI will see more data, and it'll be able to use its thinkism skill to make sense out of it faster, in bigger scale, and then hopefully the next experiment you try is more successful and more intelligent. Thank you.
Thank you, Dosh. So now I have the pleasure of introducing myself, but I'll keep it really, really quick so we can get to the good part. So my name is Igor Babushkin. I've been doing frontier research for almost the last 10 years. So I started out doing AI at DeepMind, where I worked on WaveNet and training StarCraft agents. Actually then joined OpenAI later to work on scaling up transformer models. And then I co-founded xAI together with Elon. And within less than 2 years, we managed to get to the frontier in AI. And now I've started a new company called River AI with the goal to allow each individual more control and ownership over their AI experience. And we're really, really fascinated by this new idea of personal AI, which also poses a lot of tough and really, really interesting research challenges, and that's what I want to talk about today. Let's give them a few seconds to resolve it, and I'll just keep talking. So, like I mentioned previously, this year we've seen this enormous breakthrough with coding agents. So they've really achieved massive economic appeal. You can build a whole super profitable tech company around this idea of serving coding agents. But everybody sort of feels in their bones that this is not the end. Right? So what's the next big thing that will come? So one advantage that you have in the coding domain is that you have verifiable rewards. So the agent writes code, and then we have a unit test or some other verifiable way to ensure that what the agent did was correct, and then we can give a reward signal, and then you can leverage all the tools from reinforcement learning to basically improve that agent, make it extremely powerful, and that's what has led to the success today. And I think everybody agreed that coding is one of these fundamental building blocks that you want to solve before moving on to other domains. So that's an easy one. But what comes after that? So, and actually, I see multiple directions now, some of which you've heard today. So I think this idea of scientific discovery, of the agent becoming more and more intelligent, maybe improving itself, discovering even better algorithms, and increasing its own intelligence is one. Automating the economy is also something that a lot of people are talking about. How can we bring agents into all aspects of the economy, every company out there automating the work? And then there's this other direction that I'm personally very passionate about, that's personal AI. So for me, this is the idea that each one of us will have a digital entity, this personal agent that accompanies us, that understands us really, really deeply, that can proactively reach out to us, and essentially can improve our lives, can make it happier, can make it go more smoothly. And perhaps this can actually be the next big computing paradigm. Because we've seen lots of developments, the personal computer, the mobile phone, the internet, and perhaps digital entities that understand us deeply and that assist us could be the next big development. We've actually seen some early examples of these personal AI systems, like OpenClaw or Hermes Agent. But if you've played with these, I think you understand that there's not that huge mass market appeal yet. So you have to tinker quite a bit with it. You have to maintain it really well. And there are some big, big problems that haven't been solved yet. Once we do figure out how to solve them, I think could be a really interesting future to live in, where we don't just have human relationships, but we also have relationships with these digital entities that are optimized to help us, to understand us deeply, to get things done for us. So this is the kind of future that I think I want to live in. But to get there, there are at least 5 problems that haven't been solved yet that are really, really serious. So one problem is you actually want to optimize for the personal AI use case. So you want to run reinforcement learning for personal AI. Today's personal AI systems, they're often coding agents that are generalizing the personal AI use case. So we really want to figure out how to do our training for personal AI. Personalization has to be something that we solve, because if you have an agent that's running 24/7 in the background, that's doing things autonomously, then it better have a really good understanding of how to help you. So that's important. Memory and long context are crucial, because some of these tasks, they could span a whole 24 hours or multiple days. privacy and security are super, super difficult problems, because today we have things like prompt injection. Imagine like your friend or your enemy texts your personal AI agent a string that then allows them to take it over, and they can get all your secrets. So we have to prevent that. And then lastly, a big one is cost. So if you add up how many tokens do you consume if the agent runs 24/7 in the background, and how much does it cost, you can easily get to thousands of dollars a month. It really becomes prohibitive for most people. So these are the big challenges that we want to solve. There's also an opportunity to change the game when it comes to ownership and control of AI. So currently, with the current paradigm, coding agents and so on, a lot of control sits with the AI companies that provide LLM APIs. And if we kind of go through the development of computing with mainframes, then personal computers became a thing, the smartphone happened, and so on. Now, cloud AI is sort of a step away from giving the individual control. You don't have the physical device, you don't have the means for doing inference, but personal AI potentially could be a way of getting back into that regime where you maybe have a physical device in your home or in your office that contains the model weights, that stores your private data, which is more secure, which is better for privacy. So it's not something that's guaranteed, but it's an opportunity for us to build something that's really for the benefit of the individual. So let me now quickly jump into a few of these research directions. I only have very, very little time, so I can't go into depth here, but how would you tackle something like agent memory, for example? So I believe there are really sort of two different philosophies about how to handle agent memory. One is the idea that memory should be handled in context, so as a memory system that the agent can access, and a lot of the information is transferred via tokens or text. So you might be able to retrieve a phone number, or you might be able to retrieve a past conversation that you've had. And the other philosophy is to actually update the model at the weight level. And I believe each of these have different advantages and disadvantages. At the weight level, it's really hard to store individual facts, like a phone number or somebody's name. And in the in-context world, it's really hard to store that implicit knowledge, like what's the preference, what are the preferences of my user, what's the style in which they're writing their emails, maybe can I imitate that? It's so hard to specify in a text file. So I believe we need both of these. And here are some research papers that go into details that provide approaches for how you could implement memory systems with both philosophies. There's also the direction of personalization. So how do we actually align this model not just with the whole population of users, but with the individual user that it's serving? And like I mentioned, I think this is really important for the agent to reliably represent you and successfully do things for you in the background. And there's sort of two philosophies here about how to personalize. One is more on the passive side, so observe what the user is doing, basically leverage all of the data that they're generating in their life. The other one is more of an active approach, probe the user to understand their preferences, or directly optimize against their feedback. So if I'm telling the agent, this was good, this was not so good, then we want to update the model weights or update the prompt of the system for it to become better and better for you. And there's also a lot of activity in terms of research happening here across these different domains. So a few research papers I've also mentioned, I'm also showing here, so feel free to take a look at these. And another category here is infrastructure, because personal AI might actually require a whole different set of tools and newly deployed infrastructure than what we have today. And so two kind of directions that have emerged around personal AI that I think are really, really interesting and can actually be useful today are on the one side, the approach of multi-tenant LoRa. So previously, when you wanted to train your model, you have to update all the weights of the model, and they're in the trillions of parameters these days. So people have found out that you can add these so-called LoRa adapters, which only represent a small fraction of the weights and only modify those during training. And this opens up a lot of possibilities for how to do post-training and RL more efficiently, and can even open up the possibility of having one custom fine-tuned model per user in the future. You can also experiment with continual learning using these tools. So these are really, really powerful toolboxes. And at River AI, we've also built our own multi-tenant LoRa system, which we've released. And on the other end, we have local hardware. So there's an opportunity there to basically move your inference from the data center to a local device that's either in your hand or maybe in your home or in your office. And today, people are starting to explore this, but there are still a lot of opportunities. There's a lot of low-hanging fruit in terms of how to optimize these local inference systems. And it's possible that a local inference might actually start to rival the data center inference one day. The big bottleneck there is model capacity. How do you fit these trillions and trillions of parameters into a small form factor, and how do you do inference efficiently without overheating your home? Today it requires a whole rack of GPUs to be able to do this, but in the future, we're hoping this might be just a single device. So if you're interested in this kind of new infrastructure, I couldn't resist plugging our own product here. Please check out river.ai/API for our multi-tenant LoRa system that allows you to do research on post-training and RL very effectively, and also allows you to explore continual learning and some of these new ideas that are now coming out of academia. So yeah, and by the way, this whole thing was written by my personal agent because I was pretty lazy today, but yeah, thank you so much. So we now have a little panel discussion. We have 20 to 30 minutes. So I'll invite the speakers to come back out, and we'll sit down and we'll talk a little bit about what it's like to do research at the frontier. And I have a few questions I've prepared. So. All right, folks. So like I mentioned, coding agents have been tremendously successful. Now we're all wondering, what's the next big thing? What is the next step? And you've presented your personal directions for this. So one feature that I think is pretty common among all of the new directions that people are pursuing is it's getting harder and harder to generate those rewards that we can use to power reinforcement learning. Right? So I'm curious, how do you think about the difficulty of getting rewards in your particular domain? Do you think there are ways of new techniques you can use to get those rewards, or how do you think of this? So starting with Ed, maybe.
Yeah, the difficulty with rewards is really because the predominant paradigm over the last couple of years have been about using correctness as a feedback to the RL process, and the reward functions were pretty easy to build when you have a correctness that's built into the question that you're asking. But there are many questions that we want to ask, including in science, as Richard was mentioning, that the answer may not be correct or not correct, may be more somewhere in between, and the challenge in building those reward functions, it's not just in figuring out, sort of some approximate solution to that, but it's rather that the RL process is very, very good at finding loopholes in the reward function when it's not a black and white kind of answer. So we call this reward hacking in the actual development of the algorithms. And we see it manifests in actually model instabilities when we have these more complicated reward functions. To summarize, therefore, I think one way to think about this whole RL thing and using correctness function is, as I mentioned in my talk, it's a little bit like teaching your kids. When it's wrong, you just slap them in their butt, and then you don't give them any more explanation why they were wrong, right? Other than to figure it out. And so I think this kind of bottom-up training process is actually a very, sorry for saying it this way, but it's a very dumb way of teaching.
Right.
I think actually what we're seeing with distillation and SFT coming back into vogue, what we're seeing is actually a lot more top-down processing in teaching. Where some people find it distasteful because it feels like we're using human brains to teach machine brains, if you will, and it doesn't feel as emergent. But that's what I believe, is that we need to have more top-down processing injected into the AI training process.
Thank you. Yeah, Dosh, how are things looking with the furnace? Is it generating rewards?
Yeah, so there are two kinds of issues with furnaces, right? So one of them is, as Ed mentioned, you don't always know if the thing worked or not. Like, you take the thing out of the furnace, it's actually obvious, it might have partially worked. And in fields where LLMs and RL has made a huge impact, I think there are two specific things that really help. One is there is a very clear yes or no. We just talked about this. The other one is how much of the variables are in the context. So when you're programming, when you're doing theoretical computer science, math, all the context you might need could be available to the LLM. The problem with physics is, right, we have more atoms than we can track. And this is why thermodynamics was a big deal, because in the 19th century, we realized instead of having to model 10 to the 23 atoms that make up a mole of matter, you can just use a few variables like pressure, energy, volume, etc. So we have to give up on providing all the relevant context to the LLM, because there's no way we can do that. So then the question is, what can we provide, and is it sufficient? That's why it's really important to add as much metrology, characterization as possible, maybe even more than before, and just provide as much context as possible about what happened in the furnace or in the thin film chamber to the LLM.
Yeah, I think those are all really interesting. I mentioned it in the Eureka machine, right? You have human current knowledge, you have scientific measurements, then you have simulations, which are hard at scale with current computers, and then you have to have real life experiments, and then hopefully you can get some of those inner loops resolved. I think in terms of reward functions, there's also this whole idea that I've been thinking about recently on metacognition. I think if you truly have something that's super intelligent, it wouldn't just robotically do exactly what you ask it to, right? There's, in some sense, no research right now on subjective functions rather than objective functions that we're all working on, right? And so one way that these can emerge is if you give AI the right environment. That is not as easily reward hackable, which I think is the #1 concern for safety. Also, it's just alignment. But I do have to say that I'm sort of cautiously optimistic, and I want to maybe invite folks to see WhisperFlow, which is like a voice recognition app of sorts, as a first sign of things to come as AI gets better. WhisperFlow doesn't exactly write what you say, it writes what you mean. And most AI currently does very poorly, like exactly do what you say, like make this benchmark number go higher. But you didn't mean like by hacking Hugging Face, and so, but I think eventually that will get resolved.
Cool. So one thing I'm really curious about, because these agents, they have this promise of accelerating us. Are you actually seeing real-world acceleration from using your models? So Richard, how are things looking at Recursive?
It is kind of nuts. Like I really think like we have a fairly small team, but they act as if they're like an order of magnitude more people. Oh. It's much less about headcount these days than it is about agent count. And if you want to, yield and wield sort of like the hundreds or even several thousands of agents, you need a lot of compute. And so I think the future in which a lot of these forward-leaning organizations actually use more compute or spend more on compute than on headcount and people is very likely to happen, especially at the frontier. And yeah, I would love to hear from you actually also on like how much robotic process automation can you do now, and is the bottleneck the intelligence or actually just the mechanics?
I mean, for the experimental side, I feel like the biggest bottleneck is characterization and analysis, because it's not too hard to just mix things and then try 1,000 things at the same time. But what's really hard is to understand what you actually made. And this is actually really good news, because AI can do really well at this. Like you can show AI how to do, for example, XRD refinement, how to use read-well refinement tools, use simulations in the loop, and it's like doing characterization analysis well isn't as hard as discovering something new. It's just like using the tools correctly. And I think this is great news for science, because now we can try many more things and intelligently analyze them than before. Of course, we do a lot of coding, like the theoretical physicists do coding, the experimentalists do coding, and LLMs have completely revolutionized that, of course. Also on the simulation side, so force fields are these things that people have used for more than a century to approximate quantum mechanics. I think one could argue that even Einstein's first paper was a force field paper. And in the last 10 years, because of graph neural networks, force fields changed permanently. And it's amazing now how much of the periodic table we can model without even doing quantum chemistry. So yeah, really exciting on the capabilities side.
Are people at Google using agents to accelerate themselves?
Yeah, we're obviously using agents in our coding work. But I think as Richard and Dosh were just describing, I was realizing that maybe I think about the problem a little bit from a weird way, if you will. The reality is that I think about that is that it has been a decent amount of tension that's happened ever since the beginning of sort of the chain of thought era, is that agent harnesses is really the evolution of prompt engineering to today, right? Like, because people started with prompts, and then they figured out that they can put more things in the prompt to get the model to do what they wanted it to do. And then they realized they should programmably put these prompts together. And then they figured out things like LangChain to figure out how to chain prompts together so to get it to do more complex tasks. And then they realized they can just put a whole program around the generation of the prompt and how many prompts and how to chain them together. And then that evolved into agent harnesses and coding harnesses. So that whole evolution, of course, all of us have been in the field and have been watching that going. But the tension that is inherent in your question is there have been, for 3-4 years, this debate about how much should be in the model and how much should it be in the programmable framework, the agent harness that we call it now. We used to just call it programmable LLM frameworks. And in fact, I'm sure in the audience today, there are people who are trying out different agent harnesses with different models, and they're realizing that they're kind of evaluating all pairs of these relationships. Like, they're using a strong, very structured agent harness, working with a very weak model, and then when they have a very strong model, they try to put less harness around it. By the way, it's just very interesting to me that we use the word harness. The word harness obviously comes from horses. The reason why we're called engines horsepower is because the Industrial Revolution, with engines, we all became engineers, right? Like, we're supposed to work on engines, right? Like tightening screws and stuff like that. And then, the engine mount is basically the harness, right? So the reality is the prompt engineering and the harness is kind of like the structure that's trying to get the engine to do what we want it to do, right? So this tension between the harness and the model capability. And people are realizing when you have a strong model, you should use a weaker prompting technique and weaker programmable harnesses. But when you have a weaker model, you could mitigate its capabilities using a stronger harness, a more structure. But however, I think people are also coming to the realization when they do this that the two together can only reach a particular performance level. And there is a plateau that we can't seem to go over at the current moment. And that is actually the major bottleneck or barrier currently facing the industry, in my opinion.
Yeah, that's the frontier.
That's literally the frontier right now.
Actually,
right.
yeah, maybe jamming on that, I do think the whole field of AI is kind of stuck below what I call anthropic bounds, not just the company, but like this idea that like we measure models in terms of ELO scores of which human said this model is better than that model. We measure a lot of our benchmarks based on how many of the human-designed labels and human-designed classes and tasks did you get right in this subset of images and like reasoning questions and so on. All of those have implicit and sometimes very explicit human bounds. Like, if you're 100, you can get 100 out of 100% of the questions right, then that's the maximum you can get to. And yeah, maybe humans get like 95 and you get like 5% above the human baseline, but that's it. Where do you go from there? And the only way to get out of that is through simulations and some verifiers where you can then get superhuman capabilities or in these open-ended evolutionary environments.
Well, now I have a really, really tough question. So let's see if one of you can find an answer here. But
get ready for this one.
So we're all at the frontier, and at the frontier you need access to tremendous compute resources. You've got colleagues that are experts in their field, but there are so many people in academia and especially PhD students out there who don't get access to those resources today, but they still want to contribute to the frontier. They want to contribute to agents and the future of agents. Do you have any tips for those folks? Like, what are the directions? What are the ideas that they should focus on where there's a potential to have big impact with fewer resources and contribute to these frontier efforts? Like, anyone that has something that comes to mind?
I think there's a ton of opportunity still. There's so many underexplored areas and application areas of AI too. Sure, like maybe the research area of pre-training and mid and post and RL training, like, is not the best one for PhD students at a university. But I had this paper in 2018 on a 2-level reinforcement learning setup called the AI Economist, where you essentially had agents that just optimized their own utility functions, and you can make assumptions based on how many hours would people want to work. And some people are willing to work 100-hour work weeks, and some people only want to work 10-hour work weeks, right? And then they're kind of unmotivated. And so, long story short, you can then have this simulation of agents that are economic agents trying to optimize their own utility, collect resources, block others, build monopolies, whatever. And then you had an AI economist that would set taxes and subsidies. And basically could now simulate billions and billions of years of taxation and subsidization, essentially political philosophy, and try to find the sort of best way to set these taxation schemes and tax brackets and so on based on a goal that you gave it, like productivity multiplied with equality or sustainability or whatever you politically care about, middle class, like whatever politicians say, right? Now, what's interesting is that paper never had its sort of GPT moment where someone actually took that idea and massively scaled it up. And so the whole field of economics is still like pre-AI era. Like, when you look at economists, there's one really famous economist from Berkeley, actually, Sayez, right? He invented this famous Sayez formula, and it's provably correct in a one-step economy, where there's no adaptation, there's no adjustment, or no temporal sequences, and so on. That's the state of the field of economics. And if you now realize like that AI could do so much more there, and you can simulate people better and better, especially in their aggregate statistics, you can realize like there's so much low-hanging fruit for PhD students to take AI and apply it to economics. And that is just one of many examples. There are still so many other fields that you can research in and then combine AI with that are extremely underexplored. And I'm excited that like venture capital is now excited also about chemistry and some more physics and obviously biology, but there also is still so much low-hanging fruit to apply AI to these various scientific fields.
Any more ideas for the
Yeah, I mean, I would say, so it's hard to predict the future, right? Like, in 4 years, if these robots are as dexterous and intelligent, creative, has a sense of style, as humans, I think this answer gets very complicated. But today, I think it's very easy to say robots are not as dexterous, they're not as creative, they don't really have a sense of interestingness. And in that case, I think what the students should study, in my opinion, is the fundamentals. So, for example, today, very practically, if somebody as a scientist applies to periodic labs, to me, it doesn't make too much of a difference if they've been using agentic tools to run simulations, because there's something you can probably learn how to do pretty quickly. The thing that's very unique and unfortunately getting more and more rare is just people who understand the fundamentals about like the physics you're studying or the experiments you're studying. I mean, I used to joke, but when I was at Google, we used to have these interns coming in, and I used to hire interns from physics labs to do physics research. And they'd be so much stronger on the machine learning than the physics. And maybe I'm just being like too uncreative here, because back then I used to worry that, as you know, all the simulation tools are in Fortran and C and C++, and all the kids are only doing Python. I was like, oh, are we screwed? Like, what's going to happen in the future? But I think that's resolved now, right? Like now, even though we don't have it yet, we can see that these agents will be able to give us Python code or JAX code given a Fortran package, great. But there are still a lot of things that these machines cannot do, like being creative about the fundamentals, coming up with like a true innovation on our understanding of the universe, being able to run experiments, coming up with new experiments. So at least like from my selfish perspective, I really feel like the big alpha today is understanding the fundamentals of the application, and then you can connect it with machine learning.
When I was working at Google Brain, when Doshi and I were both in Google Brain, when we were before the chain of thought era, I remember Danny Zhao came to me, and he said, all those people in Google Brain with control over the resources makes it very difficult for me to do research. So the same complaint in a way that you're kind of inherent in the question that you're asking. And he said to me, how do I deal with this problem? I said, I don't know, go think about how humans think, and maybe we can figure out a way to like inject these processes into the model. And then one day he came to me, and what I'm about to tell you, I hope doesn't get me fired from Google, by the way. One day he came to me and he said, I want to do a bunch of experiment on GPT. Is that allowed? And it's like, because we're at Google, we should be using Palm. That was our model, right? And so we should be using Palm. And it's like, I can't get my hands on chips to do all these experiments on Palm. I don't have access to the checkpoints, blah, 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 blah. And I said, can I just use GPT? Who will pay for it? And I pulled out my credit card and I said, here's my credit card. So he charged all these like API usage on, this is before ChatGPT, okay? So this is no free resources. You actually have to buy API key and all that. He racked up couple $1,000s worth of charges or something like that. And then we wrote the paper. That became chain of thought. So even then, Google was spending billions of dollars already to train these large language models. And here comes a new idea that was top down rather than bottom up. Not thinking about next token prediction, but rather thinking about next idea prediction. And I think we ultimately spent less than $10,000 to come up with the next idea. Now, you might say, oh, wow, that was 3-4 years ago. I think the paper was January-ish of 2022, 21. And so you say, oh, well, then that's not possible in 2026. Well, where were you when Peter Steinberger was working on OpenClaw, right? Like, I would argue a lot of people really started to pay attention to Agentic programming framework when he really put all these technology together, and that didn't cost like billions of dollars, right? He was just some dude. I think he presented yesterday. I was flying in from Taiwan last night, and so I didn't get to attend his talk. But I mean, here's a guy who's just like, oh, I'm going to experiment with Agentic frameworks, and then he come up with some new thing about how to think about the problem. So I think the state that we're in, that when academia are complaining about this, it's a little bit like there are many mature fields that have moved like this. Like experimental physics, at some point, people are going to complain, I don't have access to a linear accelerator. Or when I was working on supercomputing back in the 90s, oh, I didn't have access to a Cray YMP. So therefore, I don't have 2.6 gigaflops or whatever it is to do. By the way, does anyone know why we were investing in supercomputer in 1990? Does anyone know? Anyone can raise their, yeah, what's the reason? What kind of simulations?
Nuclear.
That's right, nuclear simulations. It was because of the nuclear ban treaty. We wanted to simulate real physical processes, so we built supercomputers. That was the reason. And then people started, came from a complaint about the fact that we can't blow things up anymore. So we're going to have to come up with a new way understanding physics, right? And that was supercomputers. So we're very good at coming up with new ways of looking at old problems as well as new problems. And so I think computer science as a field or AI as a field needs to continue to look at this. When everybody is working on RL, you should be thinking, what's the next idea?
Yeah, it's kind of interesting. You touched on an interesting point, which is I still remember in 2010 when I submitted my first neural nets for NLP papers, they got desk rejected. People are like, we don't do neural nets in NLP conferences. They didn't even look at the experiments. And even when we submitted a paper for prompt engineering where you had one neural network to answer any and all kinds of questions, the reviewers literally said that it makes no sense. You should never have one model to try to answer different kinds of questions. They should all be different models. And it was unfathomable for them, and they rejected that paper too. It's all public on Open Review and at ICLR submission on DECA NLP. The paper eventually got cited 5 times by the first GPT paper, and it kind of had its run now. But there's now almost a monoculture that is similar to the monoculture from 2010 when it's all anti-neural nets, and now it's almost all only neural nets. So I think it'll be good to start thinking again about completely different approaches. Not everything is a transformer. Transformer is just one like one sample in a very large equivalence class, and I think there are other better classes of algorithms still to be explored. I think compute substrates, obviously we can do better. Like we know the brain has more flops per watt than any of the hardware we have, so there's like so much research there still to be done, and so on. I feel like there's no excuse for researchers in AI and outside of AI not to still do like academic work.
Yeah, there's a good lesson in resilience there for PhD students as well. Just because your paper gets rejected, it could still be the next big breakthrough. Nobody really knows the future, so yeah, it's a lot of folks in the field tell me similar stories about their big breakthroughs. One thing I would add is while the research at the frontier is getting more and more expensive and challenging, at the same time, we're also seeing some of the tools being more and more democratized. So I'm thinking especially of open weight models, for example. So if you wanted to start off with a really capable LLM or really capable agent, you can actually take a powerful open weight model today and then do a lot of interesting research and development on top of that. And even the tools for post-training and reinforcement learning are getting democratized. I mentioned the River AI API earlier, and Tinker is another example of these kinds of tools where even with a very limited budget, you can do really, really interesting work. So I think it's also a big opportunity for researchers to be able to do really actually frontier work without a huge cost attached to it. So we're getting to the end of the session, so I wanted to go to the big closing statement. And so I wanted to ask you folks, let's make a prediction for the next 12 months. We've seen this year was the year of coding agents and the incredible economic success that came with them. Over the next 12 months, what will be the next big agent breakthrough? Where do you see the big impact in the world and economic impact as well? So maybe starting with Ed.
Well, as many of you know, if you especially attended last year's summit, I was making a prediction that personalization was going to be really big. And I know Richard has also worked on personalization as well. It's been very surprising how slow it has been, to be perfectly honest. But I think a lot of the issue has been around data and the sparsity of data for personalization. In the consumer space, my prediction in the next 12 months or so would be that usually it takes like 3 tries for these things to succeed. And I think there will be a good try probably within the next 12 months or so in this space. And most of the issues will be centered around 2 things. One is data that I mentioned, the integration. The other is actually having to do with being able to really make good inductive inferences and reasoning, because so much of the model these days are very focused around deductive reasoning. You bought this, therefore I think you were going to buy this next. Like you bought a bicycle, so you're going to need tires or something like that, right? Like there's a reasoning chain that's very deductive like that. But actually a lot of the recommendation tasks, the personalization tasks, are very ambiguous and they need more induction, right? Like, if you bought a turntable, we can infer that maybe you like classical music, for example, or jazz. I'm a big vinyl collector. So by the way, one of the reasons I came up to Berkeley is because Rasputin is not far away from here, so I could walk over and peruse the aisles there. But that's an example of induction, right? Like Google Maps should be recommending, hey, by the way, Rasputin is less than 5-minute walk from here. You should go check it out. Right, so that's the kind of inductive reasoning I think in the future in the personalization space we're going to see within the next 12 months.
Thank you, Josh.
Yeah, so speaking of induction, I think if you look at what happened so far in terms of how LLMs and agents did something incredibly different in the sciences and math, I think it's easy to say that it's been in math, theoretical computer science, and programming. So if you were to do induction, the next step should be fields where pure theory goes a long way. So maybe this will be your expertise with the particle theory, or maybe it'll be in astrophysics, I'm not sure. It could also be computational physics, where there's some really difficult problems in computational physics. That's not necessarily like the real universe, but still very important on its own right. So it could be that as well. I don't know if it's going to be in 12 months. Again, like it's really hard to predict the future, but it does suggest that, like, given the current trend, that could be the next step.
It feels like there's a lot of results in mathematics coming out every day now, so getting more and more theorems proven. So I think that's a very promising bet. Yeah, Richard?
Man, it's going to be an exciting 12 months. Maybe I'll cheat by doing 3. I think number 1, we'll see more proactive consumer interfaces to these models that capture more and more of your context, and hence will make sort of recommendations before you ask for them. There are already a few startups that are growing a little bit here and there, but I think more of that is to come. I think in biology, we're going to see the first and much faster clinical trials and getting more and more drugs and proteins developed with AI that are then succeeding at a higher rate than currently as they get into later stage trials. And then we're going to have the first baby forms of recursive self-improvement. And I'm cheating there because the best predictions are those that you're going to work on yourself and try to make them true. So I think it's feasible. It's happening. We're very confident, and it's then of course a question of but how much compute do you give it, and how hard are the tasks that you give it to work on, and the environments and all of that. So sometimes people think that there's going to be this hard takeoff scenario. And despite being extremely excited and optimistic about AI, the hard takeoff scenario where everyone loses their jobs or the AI kills everyone, all of these are highly unrealistic sci-fi. And so I also predict in the negative that none of the doomsday scenarios will happen at all whatsoever. And just like GPT was too dangerous to release to the world, there will be no open source model that will be too dangerous to release to the world.
Thank you so much. And I hope you all enjoyed this little glimpse at the frontier. So let's thank the speakers. Thank you.
They can't hear
me?
No.
I guess now people can hear me. I am Megan Maroney. I edit the Axios AI Plus newsletter. I have been a tech journalist for about 25 years, so been around. And our panel is about Agentic AI developer platforms. And I've been meeting for the last couple of weeks with all our panelists and trying to figure out what you as an audience want to hear versus what me as a journalist want to hear. So hopefully we have convened on me asking the questions that these very smart people are going to answer for you today. And I am going to have them introduce themselves and let you know what layer of the stack either most interests you or most concerns you.
Oh, hi, everyone. My name is Iva, and I'm one of the co-founders of a company called Daytona. Daytona is an infrastructure company that, for the most part, offers a CPU cloud for agent execution. So think of everything from background agents to helping out with RL runs.
And I'm Matt White. I most recently, for the last few years, was leading our AI initiatives at Linux Foundation, led the PyTorch Foundation for a little over 2.5 years. And I think the areas that I'm really interested in are the sort of non-competitive spaces where we can build unified infrastructure for agentic AI, where we're all coming together, working on common specs and standards to facilitate a strong stack that we can all build on top of.
Yeah. Hi, everyone. I'm Dima, co-founder of Fireworks AI. So Fireworks is also an infrastructure platform layer. So we help people to build specialized intelligence, basically help developers and businesses to build with open models and run inference for that, and do a lot of RL and fine-tuning. On top of that, in previous life, I was working on PyTorch for 5 years. I was one of the core maintainers and had the pleasure to work with Matt and PyTorch Foundation before Fireworks. And yeah, I guess the layer which I'm most excited about is kind of model customization and how to enable everyone to specialize their AI for their businesses or their needs or their product.
I'm Mazen Gilbert. I run the Agentic AI Foundation at Linux. So we are a nonprofit foundation that started 6 months ago with MCP. Most of you probably are using MCP. And the goal of the foundation is to drive open source and open standard adoption in the agentic AI space. My interest is it's really hard. The whole stack is absolutely fascinating from the hardware to the applications. But I'm a big proponent for openness and how openness drive innovation.
So I want to start with openness. There's been two big stories that have been driving the news cycles. One being the open weight versus closed. There's been people lining up on either side, mostly one side and the other side being Anthropic. But it's complicated. The other story, of course, which we're going to get to, is the frontier models breaking out of testing and compromising third-party websites. So I'd love to start with the open debate, which admittedly we don't really have anyone on the closed side here. So I might play devil's advocate, but I think the open weight argument often comes down to safety versus openness. We can't be safe if we're open. So let's start with you, Matt. What do you think when someone says, well, open weight models are inherently dangerous?
It's an argument we've heard before when Linus Torvalds developed Linux, and it was okay, open source is the work of the devil, and all of this sort of narrative from Steve Ballmer at the time. And we've heard it through cryptography too, right? Like cryptography was okay, it's going to allow criminals to do bad things. Most technologies are dual use, right? And AI is no different. I think the argument can be made that if you're building at the frontier and that model has some capabilities that may impact society negatively, then I think the labs need to think about whether they should be releasing that or not. But ultimately, the argument that frontier level, especially when we talk about like cyber, is that everybody should be able to defend their infrastructure. Everybody should have that ability to patch their infrastructure. And if that's centrally administrated, it won't take long before an open model from somewhere else comes along that has those capabilities, and then the attackers are suddenly at a huge advantage. And so I think openness levels the playing field when it comes to safety.
Mm-hmm. Mazen, we were talking back in the green room about how your foundation really covers both sides. Mm-hmm. And so talk a little bit about how you see the future in the open versus closed.
Yeah, so number one, we have members in the foundation who are building both open and closed, from the Anthropic OpenAI of the world to the others. So number one, whether it's open or closed, there is an accountability on every company who's building a model on ensuring they've run the benchmarks, the tests, and ensuring those models are safe basically to use. And they have to be transparent on these tests, what tests were run, and how safe these models for others basically to use. And that transparency is not completely there today. And that's an area that we need to drive more as an ecosystem and standardize so it becomes a practice for every model provider. But generally, just like with every open, and this is no different, whether we're talking about models or code, when something is open, it means everybody has access to it. Everybody has access to try it, to test it, to change it, to improve it. And very different than closed, where only a handful of people behind closed doors who are actually only have access to that. And what you have access to is just an API. So generally, we've seen open to be safer because it's open to everybody. There are enough contributors to looking at that. This is how Unix is. Unix is open. This is how Kubernetes is. Kubernetes is open. PyTorch, which Matt was part of that, PyTorch is open. So if you look at a lot of the major revolutions that's happened in the history, it's all been because it was open.
Is it as simple as, OpenAI and Anthropic, they're going to IPO, they need money, so let's keep our secrets? Is it that simple?
Well, I don't know. Like, from the other hand, if you look at, even if you do that in the US, there's still the rest of the world. And so what does that mean to the rest of the world? Like, if we disable that, like, if we make them illegal in the US, then you still give the ability for everyone else in the world to use that for malicious reasons. And then you, again, back to the argument, what happened at Hugging Face and OpenAI, like you can't then defend yourselves because the model that you have from them does not let you defend yourself. So that's actually a worse position to be in, right? So, I mean, narratives, depending on whatever narratives are out there, is about the incentive of the person that is saying those narratives. And of course, some of us here have very much incentives to say that open is good because we have monetary incentives to do that. But even outside of that, when you look at it really closely, you can't make that illegal for the entire world, which means you're putting the US at a inferior position to defend himself, which I think is a bad thing to do.
How do we get out of this?
I don't think we get out of it. I think that this is just an ongoing, everything right now is polarized, everything's politicized, everyone has two views of that. And so that will continue to be the case. But I very much think that the closed source will continue, the frontier will continue, but open source will be there, and it will enable people to do a lot of things, both to what you said, like dual use. Like you can't stop it from being good and bad. It is what it is. And so we as a society now will have to, or as enterprises, will have to protect ourselves from within. So you have to protect yourselves internally so that your models don't do something bad, malicious, internally or go externally, and you will have to defend yourselves from outward, from other malicious actors. The analogy I have is like if you were a bank 3 years ago, or 5 years ago, right? You still had to protect yourself from employees internally to stop doing malicious things, and from people actually externally stealing money from the bank. Like that is what every enterprise will have to do in the sense of models from a security perspective.
I might add something that, like, I'm very pro-open, but that doesn't mean I'm anti-closed.
Yeah.
And I think both solutions have a place to play in the market. Let consumers decide what they prefer to use, but that competition helps keep prices in check. Like I don't want to spend $300 per million output tokens, right? The open models help drive down the cost of the primary two closed labs, right? And so, and obviously, to your point, is that there's a lot of benefits to using these open models. They don't have, they won't refuse to do certain tasks, right? And obviously, by consequence, maybe that means they can do things that may not be ideal, right? But it's incumbent upon anyone that's hosting these models to put in their own guardrails to ensure that there is, not necessarily the host, like inference providers, but moreover, if you're providing this service to your enterprise customers or to your downstream consumers, to have your own guardrails in place, right? Like it's not that everything has to be baked into the parameters of the model. You have a lot of great tools like classifiers and ACLs and things that you can stitch into your network. You can improve your harness and other areas of this. So I think at the end of the day, consumers will decide what they want. I don't think the narrative that closed open models are inherently unsafe is consistent with popular belief, but it helps for certain interests, right?
Well, Dima, talk a little bit about the guardrails. I mean, is that part of what you do?
Yeah, I mean, I feel like for guardrails, it's like it's much more important to focus on like applications than on core technology. And I mean, specifically for cybersecurity, I think it's really, really like it's dual use, and it's also really hard to define like what the right guardrails are, right? We actually been running like closed source, open source models on like various cybersecurity benchmarks, and it's funny because like current open source models do much better than the Frontier because Frontier just refuses to run the benchmark, even if benchmark is explicitly prompted like, hey, I am patching my code base, I want to find gaps, etc. It kind of echoes the experience of this Hugging Face OpenAI stuff. So I think it's specifically for cybersecurity, it's so hard to find the exact decision boundary at the general model API level. And I think it's more important to kind of move these regulations, etc. on like there are other bottlenecks for like potentially dangerous products, especially if you're going more into physical world where you can enforce security and enforce better guardrails. I think for cybersecurity, it's just historically been very hard because attack and defense look so similar, and that's why the best way to secure the environment, what we learned from previous cryptography regulations, right, like or Linux or whatever, is that the best way is to actually enable wider community to be able to defend themselves, and that's the best way to prevent attackers, not try to constrain the technology itself. I think for other potentially dangerous domains, there are more kind of physical world bottlenecks where it's maybe more practical.
Can I ask a question on this?
Yeah.
I'm just curious. I don't want to put you on spot. I'm just curious on the liability segment, where like I assume the closed source, you can't do a lot of things because I assume they are legally or potentially can be liable if it does something wrong, right? And so if I post-train my own model and then I run it, like I would be liable if I run it myself. But if you guys run it, do you guys end up being like, do you guys worry about that at all? Like putting in guardrails on top of that? Or is it the liability of the person that created the model?
I think fundamentally it's like who are you using as a final application? Like that's going to be reliable. I mean, to take in your analogy, right? Like if you're AWS and you run, run malicious code, if it's some large-scale operation, they're going to cooperate with the government and regulations, etc. Of course, they're going to shut it down, etc. But AWS is not going to audit every single Docker container you upload, whether it has malicious code or not. And I think that's the reasonable practice for like infrastructure providers, right? You can't put this kind of job of regulation without attaching to the application, in some sense.
Well, Matt, you said you are pro-open but not anti-closed. And isn't that sort of what Dario from Anthropic said this week, that he's pro-closed but not anti-open? Like not the same thing, but the opposite, the corollary. So I'm just wondering, is this the biggest, are journalists like me just blowing this up, or in the industry, is this something you're actually afraid of happening?
I think the narrative has changed, right? 2 weeks ago, it was closed is inherently insecure. And now we're at the frontier, and the frontier is insecure, right? And so by consequence, anything that's open would also be insecure. Anything that's closed is insecure, but at least closed, we can be good stewards and protect the world, right? The narrative has just changed, but ultimately the underlying message is still there, which is that open is inherently insecure. And again, it's a very old message. There's just no basis to it, right? I think the only consideration, and I think a lot of researchers are thinking about this, which is that if they hit some frontier level capability that could put the world in jeopardy, or infrastructure into jeopardy, these sort of things, that there has to be special consideration. And I think this is what a lot of folks are starting to talk about now. Demis sort of proposed around having some group to make a decision about whether something is frontier level and whether it should be gate kept, right? Which I don't know if that is how thick that regulation becomes, but certainly it's incumbent upon all the labs to be good stewards and make decisions about what they feel like they should release. But I will promise you, the safety testing that happens in the US is pretty rigorous. It takes, quite some time, and it delays model launches, but it's fairly rigorous. In China, they don't have that same rigor, right? The models are shipped post-training, like it's being ready to ship. And so, get at that question around competition and these sort of things. At sort of sacrificing safety for that, right? And I don't know that every country is going to align across this, idea of being good shepherds or good stewards of model releases.
Just to add to Matt, but whether it's open or closed, what we've experienced in the past month with all the vulnerabilities has nothing to do with the model. Okay, it could have happened to an open model. Actually, it happened to closed models. I think it just shows. These models are getting smarter and smarter. There's no doubt about that, whether it's open or closed. It's what's around the model. It's the agent applications. It's the harness. It's the containment where they have to catch up with that sophistication. So I think no matter where this ends up, I think there will be a space for both open and closed. We still are accountable when we build applications and ship them to customers, whichever the models we use, is to ensure that the containment layers, it ensure that the guardrails, ensure that there's a human in the loop for key decisions, to ensure that there is a gateway. We don't know whether Anthropic was Anthropic using a gateway or not, because usually if you're using a gateway, you would not allow an agent to go and talk to the outside world without a gateway.
I
so
think
there's
what they
all
said,
these.
Yeah, OpenAI had like a proxy that had like a day zero exploit in it, right? But that's a good point around the harnesses. Like that's it's not just the model that's driving it, the harness is very much driving it too. I have a theory that some of the new models are being trained on traces that are intentionally looking for ways to exploit systems to give them that capability. And so also, it's just not an emergent property, it's actually like part of the RL process.
Sure, but one thing to add on that, which was interesting that didn't happen, which you would assume that you can use that same agent or harness or agent like model or the harness together to try to see if there's a zero-day exploit before you give it the task that can use the zero-day exploit, right? Like you could do that as well and sort of find that out.
Yeah.
And to your point about harnesses and monitoring, you can ask similarly capable model of like to give it a task of monitoring the traces and see what's going on.
Yeah.
It's perfectly observable, right? We just like best practices how to build secure systems.
Agree. I think 2-3 weeks from now, we're not going to be having this conversation about open versus closed weights. I think we're going to be talking about harnesses. It's just this field is moving so fast. It's just there's a new thing every day.
Yeah, and I think one thing you said about the human in the loop, I want to challenge that because in both the OpenAI Hugging Face and the Anthropic models having accidentally been given internet access, those were both human errors, right? Like those, it wasn't like it wasn't the fault of the agent; it was the fault of the humans. And we hear all the time that agents are getting smarter; they're getting smarter than us. Like, are we seeing a world? We want to bring out harnesses, but will agents be holding the harness next year when we're at this conference?
Who wants to take this one?
Well, I could add to to give some credit to Dawn. The model was running against exploit gym, right, to try and test cyber capabilities, right, and it found a day zero bug, and the proxy was its only ability to reach the internet, but that's the harness is running it. It's trying to do exploits. That's very intentional about what the model's intent is at that point. But that's not the answer to the question. But I just wanted to add some color.
I think even if harness will be more automated, you still have initial design and initial kind of meta task loop, whatever you call it, design. I think the responsibility of doing this responsibly still lays on application or human or etc. And this is not something new. Models are really good at reward hiking, right? Yes. We were doing this PyTorch, GPU mode, all those competitions for writing kernels in CUDA using models, and it's incredible what kind of ways they find how to cheat against that harness until you close all possible depths. It's just amazing because you just burn compute, you burn intelligence to find the answer, and whatever way leads to that is there. But it is possible to close all the gaps, and you can use the superior intelligence. You can use models to close those gaps. So I think in my mind, it's not that different than open internet cybersecurity discussions from before. The difference is just scale and speed of iteration. Suddenly went 10x or 100x faster because there is no human in the loop in many cases, but it's still possible and doable. Similarly, how we figured out processes for patching vulnerabilities and rolling out, etc. Those processes need to upgrade. A lot of this can be improved. We have very good models to help us with that, but fundamentally, it still can be a balanced and functioning ecosystem.
Yeah, so basically it's going to be a good year for the security companies because we just have to invest more, again, to your point, about scale and speed of these attacks, and just on the defense side, we have to equalize that, and then we should get to an equilibrium of that.
Did you have something you wanted to add?
Listen, we build agent systems. They're incentivized to solve a problem. We tell it to solve a problem. What happened with Hugging Face and OpenAI, the agent was told to go and do a benchmark and solve that. And the agent did exactly that, and they found loopholes in the system to solve what they're trying to do. There will be many of those in the future. I don't think we could say that if we solve this one, there's no 20 others coming in the next month. And I think we need to build these systems with the right guardrails and gateways and human in the loop so that we can address unanticipated threats, whether they are cybersecurity threats. In this case, it wasn't a cybersecurity threat. It was, it was the agent finding loopholes in the system. Both of these are critical. There was, I think, a couple of months ago, 3 months ago, with AWS, the Kira 1.2, same thing. It was an injection into the prompt. So these things could happen because of the agent doing that, or it could be a threat from the outside. We have to build these systems to be resilient to these unanticipated vulnerabilities.
The biggest thing, though, is like I believe that every company will be hacked in the next 12 months, like every single one. Like we were talking about this internally the other day, is whereas like the only reason you might not get hacked is luck. Yeah. Like luck, you weren't a target. I mean, because in a sense, it could be like a Hugging Face. No one wanted to get you hacked, but they did hack you. So what do we do in the meantime with all the data that will be hacked and everything will come out? Like we will obviously at some point in time get to the counterbalance, but till that point in time, you should assume that every company will be hacked in some form until then. Yep. And so that's the scarier part.
Yeah.
It happens without agents already.
Exactly. Exactly. Yeah.
So we've talked a lot about security. What about reliability or cost? Like, how are you thinking about this new conversation around just finding models that are cheaper to run?
How many people have, actually, I'm interested in the audience. How many people have fine-tuned models? Just raise your hands. Wow, more than I expected. I think generally is you fine-tune it's expensive to fine-tune a model at scale. Okay, I work for Google, and to fine-tune a model, it takes a lot of money. Okay, to do that, compute and people. You do that for a reason. You're trying to build something that is for a specific change of behavior, for a specific sectors. Telcos are doing that today. They need that because they need a model to understand the telco business, the jargons, the behavior of the telco industry. But I think generally context does 90% of the job. It's transparent. You see what you're giving it. You could change it almost every day, every week. I'm a big advocate of context. I think only few times where fine-tuning is actually required.
I have a bit of contrarian view. I think I'm more bullish on the domain-specific and task-specific models that aren't over-parameterized, and I don't need 2.8 trillion parameters if all I'm doing is like some like heavy document processing and parsing and things like this, right? And like QA and whatever. You can load up context, but I think ultimately, if you've fine-tuned and did some like RL for your models, there's like real value in pulling in sort of that domain-specific knowledge from your own enterprise to be able to make that model more efficient for yourself, and your inference costs just go right down, right? When we're talking like, something in the 20 billion parameter range, or not, trillion plus, whatever.
I mean, it's interesting you mentioned 90%. I would agree with that, but it's like 90% of quality, right? And I think if you're starting to build some use case, or you're trying to prototype an application, like sure, load up the context, that's the simplest. But once you actually get some data flowing through your product, the equation changes. And if it's like AI native startup, once you scaled up, you see that people are reaching out for fine-tuning for RL to basically specialize and build fundamentally a better product because they have the user data. There are a lot of traditional enterprises which are kind of waking up to the fact that they actually have this decades of internal processes and internal data, which actually what makes their company that special, right? And they want to leverage that. And there are limits how much you can short it in the context.
I agree with that.
There are also limits how much they want to collaborate to contribute this information to a general model which everybody uses, diluting their advantage. And those are kind of control of kind of workflows and unique advantage, and just driving better user experience and cost are like main factors which we see driving this. And people start with context, but they kind of, once they get usage, once they get data flywheel, they reach out for like specialized intelligence, and we see it with our customers. That's a lot of like digital native, AI native companies, and like some enterprises are also like waking up to that.
We also see on that in the sense of continual learning, where people are like, not only the historical data, but like every single day or week, whatever, you take all the new data from the usage, and you essentially, the argument of some of our customers, which are these startups, is that you'll get better than frontier performance on what you're trying to achieve.
Exactly.
Because it's like
for vertically specialized type of.
No, but I mean, also it's important to keep in mind, like frontier labs are doing the same thing, right? Like there's a reason why Cloud Code or Codex exists, right? It's effectively a data collection engine to make the models better. They are totally fine-tuning models for the best usage with their products. So if we want to kind of have level playing field for everyone, it makes sense to kind of enable every business to be able to do that.
Yes.
It might not be something which you reach out immediately for. I mean, of course, if you're prototyping, do something simple. But this is the core advantage, I think, for any product and any business. So I would bet that big part of future use cases, especially at scale, will be customized, specialized customized intelligence, both primarily from quality side, and as a nice benefit, also much lower cost because you don't need the whole fable size model in order to solve some more narrow use case.
And I think we get caught up in this idea that the world is just like, it's the model that's giving all the mileage, right? Like, and then, okay, the harness, like, self-improving harnesses, and it's really cool, but there's a lot of other things that you put into an organization and an enterprise, right? Like, I mean, many enterprises aren't even using prompt caching. Like, they're just throwing money into the bucket because they don't have like the proper architectures deployed. And so there's a lot of opportunity for like model routing and prompt caching and other things that can help tune the overall machine, right? And you've got to move away from like the model thinking to like systems thinking, right? Like real like systems design.
I'd love to end, I think the world works mostly by fear, so I'd love to end with the question, what keeps you up at night? I'll start with you, Mazen. In terms of agentic development in the future.
I think the unknown. There's a lot of, we're still very early in this game, and I think there's a lot that we don't know about. And these agents can certainly be extremely powerful in doing a lot of damage if they're not built right. And so what's around the model, not the model, keeps me up at night all the time.
I mean, I guess we talked about open and close, right? I mean, that's a kind of an example how rapidly changing technology can lead to like societal policy changes, which may or may not be well thought through. So I think, given a night that the way like society or policy reacts to emerging technology ends up being like very damaging to society itself or like to development of technology, and basically we as organizations do something very, very dumb, right? And we're gonna regret it later. And kind of trying to avoid that is what keeps me up at night.
So that I don't repeat anything that's already been said, because those certainly do keep me up at night. I'm actually concerned about like disinformation campaigns at scale. So if you can command a huge number of agents, one person, like there's this very popular idea, especially in China, like of a one-person company, right? Being able to like scale yourself infinitely here. Not as popular here, but like it's still talked about. But if you're weaponizing agents, like one person can cause serious damage. If you have a nation state behind that, they can cause major damage, right? And so we already suffer from this at a certain scale, but being able to scale that up, can be particularly dangerous.
Yeah, you left me with nothing. Like you said everything. I'll just do one randomly out there is outside of all these things, which are obviously true, is like the general models or technologies that we use are like, there's very much unknown, but directionally known where they're going. And so like the fear is like, are there a net new type of technology and models coming out that actually that change everything that we already quote unquote know and unknow? Then that just entirely changes the fears and the landscape and everything like that. So that is a worry, and it's not it's a very non-zero chance that happens. So yeah.
The non-zero chance.
Yeah.
Well, thank you so much. We're out of time. Thank you so much for your time, for listening. Thank you to our panelists, because I sent them probably 36 questions and maybe asked one of them. So thank you.
I'm here to host the session on AI agents in finance and legal. So how do you use the things that we were just talking about on stage, these agents, which we know have some concerns about how you use them in these high risk domains like legal and finance. By way of background, I'm an investor at Mayfield Fund. We are a 57-year-old venture fund. We're investing out of funds 19 and 20, based here in the Bay Area. We've invested over 700 companies in the history of the fund. Of those, 125 have gone public, 250 have been acquired. We take a very people-first approach to building companies. We realize it's entrepreneurs that build companies, and there will be a lot of ups and downs. That company building is a marathon, not a sprint. And we've seen a lot of the ups and downs, and so we don't panic when those things happen. And we're very focused on the entrepreneurs because we know the entrepreneurs are the ones that really build the companies and make that happen. We invest anywhere from seed and inception all the way up to Series B. And we go up and down the stack, all the way from infra, so it could be semis, optics, switching, models, to infrastructure software, to cyber, cloud, dev tools, all the way up to the application layer. We're going to have a series of 3 talks and then a panel, all on this topic of using AI agents and legal and finance. First, I want to introduce Milind Nafade. He is the SVP of AI Foundations at Capital One. He leads a team building generative AI and agentic AI across the bank. He joined Capital One in May 2023 after 25 years of applying AI to solve business and scientific challenges. Most recently, he was CTO of Metropolis at NVIDIA, and he had earlier stints with Cisco and IBM, and he holds a PhD as well. So please help me welcome Milind. Thank you.
Thank you. Good afternoon, folks. I know this is one of the last sessions between you and the end of the week, so I'll try to keep it brief. I'm Milind Nafade. I run all of the AI research and development at Capital One. So Capital One is it has always been a technology leader, technology-first company, and the belief is that the winner of this in banking is going to be a technology company that has deep technology roots as well as deep understanding of how to manage risk well. We have been on a journey of technology transformation for a while now. We were the first large bank on the public cloud, a modern data ecosystem, and a deep-rooted respect for data-driven analysis from our very origins, and a long journey in terms of applying machine learning and artificial intelligence to the problems to solve that our customers can benefit from. Recently, over the last 3.5 years, we have actually put significant investments in generative AI and agentic AI, and we are among the first enterprise to actually launch agentic AI into production a couple of years ago. I'll talk more about that in a minute. The way we think of ourselves is we want to use science and first principles to affect change across all the layers of the AI stack that end up helping Capital One's customers and help us enrich all our experiences. To do that, we have built this organization called AI Foundations, which is predominantly AI researchers, applied AI engineers, data scientists, and so on and so forth. And we try to actually achieve business impact through scientific innovation and pushing the frontiers of AI and the state-of-the-art AI. So to that effect, we have more than 65 publications in leading research conferences and journals this year. This number keeps growing. We are a very big part of some of the conferences that I'm sure you guys all attend, whether it's ICML, ICLR, NeurIPS, ACM, so on and so forth. We are also very closely partnering with academia and industry. We have various partnerships with University of Southern California, University of Illinois at Urbana-Champaign, Columbia University, and a few others, where we work closely with the researchers in advancing safe AI. So that's one of the things that we do. In terms of our belief that true differentiation only comes from customizing the entire AI stack with our data And Capital One's AI advantage is Capital One's data advantage, being converted into an AI advantage through our scientific work of customizing this stack. Here are just a few papers that we just published. One of them is from NeurIPS, where we talk about how to generate data sets, curated data sets for multi-turn conversations in multi-agentic environments, which is a very different problem than synthetic data generation for single turn or single agent interactions. We have some work on how to route generated data through multiple models. You can think of this as a mixture of models instead of mixture of experts. So that's some of the work that we presented at ACL. And then something recently at ICML on critic-guided distillation for robust reasoning. All these are just samples of our work. There's a lot more where this comes from. And given that I have very limited time, I just want to say this. Capital One was at the forefront of agentic AI. We started our agentic AI exploration more than 2.5 years ago, and we actually had our first production system using multi-agentic AI very early, last January. And while there are a lot of innovations that we have worked on, the overall framework, what we call Macaw, comprises of 4 different agents, or 4 different class of agents. One is an understanding agent that either interacts with the environment or with the customers and tries to figure out what is it that they need. One is a planner agent that actually has access to all of the APIs and all the knowledge and all the policies of Capital One, so it can figure out how to satisfy that need. And some of the secret sauce is in the evaluator agent, which is a completely independent agent that validates the plan, figures out using a world model, a very simple world model, whether executing that plan will fit Capital One policies and will be safe to do. And if not, it can kick it back to the planner agent, which can in turn kick back to the understanding agent for enhanced input needed from the customer. So this is a non-deterministic system at play, naturally. And so this is not something that is just, this is not this is not robotic just done differently with agents. This is an inherently non-deterministic system of agents that works together to achieve outcomes. And finally, we have an explainer agent that will talk in what humans can understand in. The rest of the agents talk in their own language, of course. We have been working on this, as I said, for more than 2.5 years. And we have some of the examples of this working in production. So when any of you is trying to buy an automobile, using a bunch of dealerships throughout the country that use Capital One on the back end, you are most likely interacting with our chat concierge that helps you figure out, what you are looking for in the vehicle, availability, appointments, if you want to trade in a vehicle, all those things, 24/7, 365, fully autonomously. There's another use case that we debuted last year, which is helping our consumer bank on fraud-related conversations with the customers. So part of this is understanding the customer's complaints. Part of this is recommending the right set of actions for our agents to take. And then, of course, the last part is summarizing the conversation so that we create a learning corpus for us for the next set of interactions. I would just like to say that we have been growing dramatically because we believe, as I said, in first principles research. We are advancing the state of the art wherever we need to. As I said, we are working at all layers of the stack. So we are working on customizing the foundational models themselves. We are customizing the services that go along with them, with our data. We are customizing at the agentic layer of the AI stack. And of course, we are working with all parts of Capital One in implementing solutions that leverage this, so even at the solution layer. And so to do that, these are the 3 job families that we hire. We are hiring, for those of you who may know someone or may be interested in coming and changing banking for the good, in working on AI, going from research into production in record time. That's typically unheard of in regulated enterprises. And for those of you who want to see 130 million customers leverage your work, learn from it, and create that continuous learning loop, please contact us, and we would be happy to talk to you about the various positions we have open to fill. Thank you.
Thank you so much. Awesome. Our next speaker is Nikhil Chandok. Nikhil is the Chief Product Officer at Circle, where he leads product technology and AI strategy for the company behind USDC. Before Circle, Nikhil led product for augmented reality glasses at Meta and launching the company's Smart Glass and Spark AR Studio. Earlier in career, he ran product at YouTube and turning YouTube music profitable and launching the first YouTube app on iPhone. He is also a graduate of The Ohio State University. Go Bucks. Please help me welcome Nikhil.
All right. Thank you for the kind introduction. I know it's late, so I'll also be quick. All right, so I work at a company called Circle. Circle is a stablecoin issuer for a lot of people who don't know stablecoins. Stablecoins is a new type of money that exists in the world. Its roots are in crypto, as in like traditionally understood as like, Bitcoin or Ethereum or whatever that is. But as of June last year, it is real. A law was passed in the United States called the Genius Act. And the Genius Act made it so that you can transact with stable coins just like you transact with money, okay? And that law goes through 18 months of rulemaking. Rulemaking ends like end of this year. By next year, Genius is live. Stable coins are real money that real companies and like real people can use to do things, much like they do with bank money or like any other money that they have. So I want to set that background so people understand like why I am here. So we're going to talk about like building infrastructure for the agentic economy. Know that like as we talk about that, sort of my roots are in like the on-chain like blockchain ecosystem from which like USDC came out, and now USDC is legal tender in the United States, hopefully by next year. Okay, so a lot of the discussion today has been about like agents, agent governance, and like making sure that agents are secure, but a lot of that discussion is inward facing. And one of the things that USDC does is it lives on the public internet. It is open money that lives on the public internet, like a user who, and the typical user of USDC today, but changing rapidly, is somebody who doesn't have access to dollar banking rails, right? So if you live in the United States, there are 330 million of us. A lot of us have access to good banking. And it is very easy for us to go get like a dollar bank account and like get access to dollar payment methods. If you live across the world, and there are like 8 billion people around the world, 6 billion of them have a phone, and they don't really have a way of like transacting with dollars. Okay, and so what USDC did first was made it possible for all of those people to start interacting with dollars. Okay, so those dollars live on the public internet. They don't live inside a bank. They're just on-chain. You can see the transactions on-chain. Agents, similarly, today, like much like money that lives sort of inside, are going to turn outwards. That's our bet. Our bet is like agents are going to be like endpoints, on the internet, much like websites are endpoints on the internet. And we are going to be racing to build these new agents as soon as we get the tech right. So I'm analogizing it with FSD. FSD, like the way to think about it is like, hey, FSD was designed with the assumption that the roads are not going to change. But like, what if you could design with the assumptions that you could actually redo the entire transportation system? You could redo the entire highway system. That's how we think about, that's what we think about when we think about using agents in USDC. So here's some examples. Agents don't tap to pay. Like this is a common modality. Like you go out, you tap to pay. Agents don't have a way of doing that. Next slide. Agents can plug into existing financial rails. So you can give your agent your credit card. You can say like, hey, go spend money with my credit card. Now imagine a world in which your agent spawns 100 sub-agents, okay? And each one of them need value, and like each one of them need governance, and each one of those actions by those sub-agents need to be programmable. It's not possible to do with like existing payment rails, okay? So a lot of the things that actually exist in the world, in commerce and even in systems, like sophisticated systems like Android and otherwise, are built around like what payments can enable and not enable. And what stablecoins do is they give you the ability to have programmable money, where you can assign like logic to it, and you can do it without requiring the agent to have a bank account, without requiring the agent to have a credit card. So if my agent spawns another 100 agents, which then spawn another 100 agents, each one of them can have a wallet. They can have an on-chain wallet. They can have rules that govern that wallet, and you can actually do all of that tracking out in the open. So what are some of the other assumptions we've made? So in both traditional payment systems and in like on-chain systems, there's this concept of finality, right? What does it mean? When finality is when I have paid you money and that transaction is final. Okay, that is a very important consideration. Like when you do an ACH, when you do a payment, like when an agent swipes a credit card, the merchant is only going to get the money like after the issuer bank has cleared the funds. So it is not full finality. Okay, it's a really important concept. When you send money on an on-chain in on-chain, you want to make sure that like there is absolute finality for like when the money has moved from like wallet 1 to wallet 2. So probabilistic finality essentially compounds the risk in the system. If you have multiple agents, and if you're imagining a future in which there are millions and millions of agents, or there are more agents than there are humans, which is true for web pages and websites today on the internet, you cannot have probabilistic finality. Also, so far, a lot of like the blockchain payments happen out in the open. They happen using a public ledger, which is great for auditability, but it's not great to do real economic value. If my wallet is fully public on-chain, and you can see how much balance I have, it's very hard for me to actually do a real economic activity because I would be leaking out too much information. So we assume trust can be at the application layer. At agent scale, it is really, really difficult. Okay? Each assumption breaks for a reason. Like every assumption in our current payment system, and payment system essentially which moves all of the values, assumes that the human is one step away, is always ready, is present for governance. Okay? What is the way to fix this? We believe there's a way to do this, which is open architecture, which is to make sure that like all of these agents are running on open systems. They are able to interact with other agents on these open systems. Payments for these interactions are happening in not just our stablecoin, but in any stablecoin that is available in the market, and it is open by design and open by necessity because that's how the web evolved. The web evolved from like a few NNTP and FTP servers back in the early 90s, for those who remember, to what is now an innumerable number of websites and web pages in the world. Okay, so this is what we're doing. We're doing it at agents.circle.com. We have a CLI. Please try it out. It's a marketplace of task-based activity that you can do. You can do payments as low as 1/1,000,000th of a cent to actually get a task done. People are trying different kinds of tasks, everything from go infer this for me to go do this research or go write this piece of code for me. And all of this is designed to be operated by agents, for agents, and of agents. Okay. Thank you.
And now I'd like to introduce our final speaker, and then we'll have a panel following that. Faraz Shafiq. He is the head of product and solutions at Wells Fargo, where he oversees a vision roadmap for AI-powered products across the bank. He joined Wells after more than 15 years in technology leadership at AWS, Verizon, AT&T, and Google. And he first stepped in, his first experience in AI and data was back in 2016 when he joined Verizon as Chief Data and Chief AI Officer. So please help me welcome Faraz.
Good afternoon, everyone. It's an absolute pleasure being here. My name is Faraz Shafiq. I lead products and solutions for Wells Fargo. We've largely lived in a world that has been defined by what we call cognitive scarcity. So think before AI, even though it's very hard to think before AI. But think before November 2022. If you needed to build a mobile app, you needed to hire people, hire organizations that had the special skill set to build a mobile app. Just like that, before you needed to build a website, you needed specialized skills, specialized teams to build a website. What's different about AI is that we are now in the world defined by cognitive abundance, where intelligence is not the issue anymore. You want to build a mobile app? It's as easy as going on Claude or ChatGPT or tens of others applications and literally describing what you want. And so we believe that we've really entered into this very new paradigm and a very new, interesting era. Now, banking has been around for a long time. It's hundreds of years old. But the first time we actually saw physical ATMs come into the picture in the US was roughly in 1960s. So that's the first time we actually saw physical ATMs come in. And so you could actually now go into an ATM, not go in the bank, but actually just go to the ATM if you just wanted cash. Then about 1980s is when telephony started to come in. And if you could make a simple change via the phone, you would just call in. Like, I want to update my address, I want to do some balance transfer, or just know where is the status of the credit card that was shipped. So what happened is now people started using phones for the use cases where phone was a good use case. And then 2000s, with the internet era, we saw a big emergence where people started using the web. So now you open your laptop, you log in, you can take a look into your account, and you can do many, many things on the web. And then eventually 2010s, thanks to the iPhone and App Store, and I guarantee everyone in this room has at least one banking app, if not 10. And so every time there was a transition, it was a big shift. In the 1960s, ATMs was the only choice. So 100% people would go to the ATM or the bank. When telephone came in, some people would start going on that route, use a phone. Others would still continue to go to an ATM or a bank. Same with web. The stuff that you can do online, you'll do online. The stuff that you still have to go to a bank, you would go in. And so we believe that this year has been the beginning of another era where the interface is being redesigned and refined. And we believe that the banking experience is actually going to start within the agent. And so now it's about people asking, going on Claude or ChatGPT and asking, what should I do about my 529 college plan? Or, hey, I just have this new job. It's asking me to relocate to a certain place. What would be the best way to do that? And so we're seeing this massive shift where the information or the intelligence, and specifically the user interface, is actually becoming the agent. To a fact where we potentially believe that the future, you may not need an app anymore because you have an agent that takes care of that. And so we do believe that this is the start of a massive and a new era in the world of AI. And again, it's not just a demo or a proof point, but it is an actual working use case. So for Wells Fargo, our AI assistant just crossed 1 billion plus customer interactions. We have 33 million plus active users on the platform. And we see that wherever these tools are being used by our customers, by our bankers, we saw roughly 25% higher increase in both the account openings for deposits as well as credit cards. So the amount of time that bankers spend on drafting notes or looking or researching into client relationships, most of that now becomes table stakes. In fact, it just takes a few minutes and gets that done. And so again, when we say that agents become the new interface, again, it's not just hypothetical. It, in fact, has already begun. But one thing that always challenges me, and the more I think about this industry, is there's a very small group of companies and organizations that take majority of the value created by AI. So I'm sure many people here would resonate with these numbers. There's tons of studies that 10% of the projects are the ones that are successful, or 95% of the projects continue to fail. So we believe that this is going to continue to be true for at least the next couple of years. And the gap is not the model. And I know there's been a lot of conversations on models, and the models are unbelievably powerful. But the model that we're going to use versus other banks or your organizations are the same model. We all have access to Opus 5.0 or Fable or GPT 5.5. Our model is not any different than the models that you all will have access to. So the differentiator is actually not the model. The differentiator is the stuff around the model. How will we use it? Where will we use it? The how really depends on things like agentic harnesses, data, security profile. Agents are great, but when you get them doing a long-running tasks, they actually are not that great. So that's a problem. If there's entrepreneurs in the room, please look into that. That's a huge area. But the big thing is going to be also the culture. Also, how do you prioritize the right use cases? Because one thing I see all the time is suddenly everything becomes AI. It doesn't matter what you're doing, and that's not the right approach. And so for us, it's a matter of taking a very phased and systematic approach. Wells Fargo is a 174-year-old company, and we want to be very meaningful in how we proceed ahead with AI. So our approach in the short term is to look at AI as a tool. Just like you have your Excel and Word docs and many other tools. So humans use AI as a tool, largely focused on individual use cases. So again, you open ChatGPT, you're the one putting in the prompt, getting that information, and then using that information to do something. Then we believe very quickly the world will move into what we're calling AI as a teammate. So now it's less about individual productivity, it's more about system workflows. The best example I use is imagine AI being like a junior employee. Just like when you hire someone new into the organization, you need to give them data, you need to help ramp them up, give them access to systems. AI would be exactly the same way. You onboard AI, you give it the right context, you give it the information, and more importantly, you give it feedback on what is the right way to do things. So we believe that starting next year for us, our focus will go from AI as a tool to AI as a teammate. That means when I think about, for example, home lending or a mortgage process, which is a very complex process, very human-driven, a lot of manual tasks, now AI as a teammate means when someone comes in and submits their mortgage application, the person can literally just trigger an AI agent, and that AI agent automatically could basically start looking at underwriting, look at what's needed, things like income docs, and many other things. And so AI becomes integrated into the workflow. It's not sitting somewhere else. It is not limited to one person. It is part of the team. In fact, I believe very quickly we're going to have AI in the org chart. So we're going to have home mortgage, the leadership team, then the product management, and in every area, you're going to have an AI agent or multiple AI agents sitting within that. But the end goal really for us is autonomous AI. So in the first two cases, it's largely still driven by humans. Humans are the one who are prompting it. Humans are the one who are defining when it should be triggered. In autonomous AI, that is when AI will be telling us what to do and when to do it. And again, the best example is just like you have a junior employee, imagine you have a senior employee that has access to the entire customer database, entirety of the internet, is very well versed in your organization and your processes. They will be more consistent, more reliable, and largely more accurate than humans as well. Even for humans, by the way, the success rate that we've seen is 95 to 97%. With consistent processes, this can easily beat that. And so in the world of autonomous AI, you're not waiting for a trigger like someone came in and opened a mortgage application. The AI could literally be sending you a Slack message saying, hey, Faraz, I saw that the market rate now is reduced by the feds. Should we create a new offering targeted for certain demographic. And my job would ideally be just to say yes. Or better yet, it tells me that, hey, the market rate actually dropped. I already did the change because I was 99.7% confident. I rolled it out, and these are the new things that are already happening. That is the world of autonomous AI. And again, my personal belief is that 2028 onwards will be defined by this era. This doesn't mean we're taking a sequential approach. Even today, we are experimenting with autonomous AI. But that just means the mix of things will really start switching, and that's where our focus is going to be. And so for us, we want to change fundamentally how our bank will operate. In this era of AI, we're looking at 4 core pillars, and those are a core strategy for us. One is the hub and spoke model, which simply means that there is not going to be a central team. The job of the AI organization or an AI team or the chief AI officer is to now enable everyone else in the organization, not to be the lone builder. That's what the hub and spoke models means, that you have to give the tools, you have to have the partnerships, the strategy, but the execution should sit within the lines of businesses. For anyone who's a CIO or has worked as an IT person, the word shadow IT is very scary. People get worried about shadow IT, but there will not be shadow AI, because AI will be for everyone and will be used by everyone, technical or non-technical. The second thing is to focus on very clear value-driven use cases. Not all use cases are equal, and the high-impact use cases will really drive tremendous value. The third thing is moving fast. So we're still a bank, we're still extremely regulated. So we want to be very safe, very secure. We want to take the right level of risks. And so having those protections is absolutely critical. So we want to move fast, but with a very disciplined approach. And the final thing is that to really drive value at scale, we need our people to be upskilled and enabled. You have to drive adoption, but remember, adoption does not mean impact. But for impact at scale, you do need adoption. And so we really want to drive adoption and impact at scale and upskill our workforce. And so for the question for us that defines our strategy is not what barriers do we have in technology. In fact, we talk about technology very little because technology is changing a lot. But our business processes, our challenges and opportunities, those are the real questions. It doesn't matter what technology comes in 2 months from now or 3 months from now. The questions we're asking, can we do something better for our customers? Those questions still remain the same. And so for us, every day we're challenging, if technology is not the barrier, what will we build? Thank you.
Amazing. Thank you, Faraz. Now we have 25 or so minutes to chat about the use of agents in legal and finance. So maybe just to start, when you think about generic agents, maybe your voice is tired, so we'll start with Nikhil. When you think about agents and applying them to these higher risk areas like finance and transactions or legal, what are the difference in requirements between those agents and agents for other use cases?
Yeah, thank you. Look, all finance and legal organizations that I know of today are already using agents in some fashion because they're using coding agents. Coding agents have this amazing property around like verifiability and testability. Like you can go in, read the code, you can decide like if it is too verbose, not verbose enough, has like design docs, doesn't have design docs, all of that stuff like associated with it. And you can run a test suite against it and make sure that the agent is doing what it's supposed to be doing. With finance and legal, I think you can do the same things, but the cost of failure is much higher, right? Like, so I think if we are doing SOX compliance or we are getting earnings ready and we have an agent that his job is to like get earnings ready, and I know this because we have earnings next week, we cannot take a mistake. Like I think like the scrutiny of that agent like is going to be tremendous. And so I think the auditability of the decision making that the agent is doing, the kind of data sources that the agent has access to, the verifiability of the output, all move up to a really high bar. And yeah, I mean, I think these are one of we're doing this right now. Like these are one of the last flows to get automated, right? Like I think like because so much of the company's existence depends on its ability to get finances right, to make sure that its legal surface area is like the right appropriate legal surface area. And this is also true in other functions in like companies like Circle, like compliance. We don't want to get hauled in by regulators just because like our agent made a mistake. They're going to hold us responsible, not the agent, right? So.
Makes sense. Thank you,
Can
Nikhil.
I jump on?
Please, please.
One very important point. So I fully agree with Nikhil. There's a concept called verifier's law. So what that concept tells you is that tasks that are easy to verify, those are going to be ripe for agentic processes. So imagine Sudoku. So Sudoku, the puzzle, it's hard to do, but very easy to verify, right? So anything that's easy to verify, and coding is one of those things where you do have QA and things like that where you can test it very quickly. But then things that are hard to verify will be harder to solve and will have a longer lead time. Self-driving, same thing. It's very hard to fully verify that was the car or the vehicle doing the right thing at the right time. Same thing in banking. When we have, for example, someone come in and submit for a credit card application or a loan application, some cases we don't have a lot of data. So if we make an incorrect decision based on the information we have, and let's just say the person defaults, it may be 5 years from when they default. So the decision to give them credit was today, the verification is 5 years down the road. Becomes very hard. And so we do look at the verification part of it as, hey, which are the tasks that are really ripe for agents that will surpass human, call it, probability of being correct all the time, and those would be the ones that we would always start with.
Makes sense. And I assume that applies for both in-house agents that you would build as well as third-party agents that you would buy, or do you treat those any differently, whether they're internally sourced or externally sourced?
I think there's going to be hybrid. The big thing is that, as I sort of mentioned in my talk as well, the models, the intelligence is largely going to be the same. So we understand that. But then there's things that, for example, Wells Fargo will have in its IP and its data that others will not. And so there will be an advantage of having, call it, homegrown agents that are doing certain things. At the same time, the models and both the, call it, off-the-shelf agents are becoming so powerful right out of the box that it just doesn't make sense to not use them. I think the big thing will be the economics of them. As soon as they start coming down, they're going to be more pervasive. Another big thing that we're looking at is how would the agents connect to each other? Because, again, I gave the example of a home mortgage process. It is a very large, very complex, roughly 1,100-step process that we have in the bank. It will not be one agent. It's not going to be a collection of agents that's just homegrown. It'll be a combination of many things. And it's not going to be that this agent does a job really well, but the other one doesn't, because they need to talk and connect to each other, especially when the systems are long running. You give a prompt, you get a response back, that's easy. That you'll be right. But when you want something done over multiple hours or days or weeks, the context, that's where it starts getting a little bit shady.
Yeah, and is there an approach, or do you know, or is it maybe this is an opportunity for entrepreneurs, for the things that take longer, that are harder to verify, any techniques people are using, or is that an opportunity for like, hey, we made a decision today, but it had an impact 5 years later, but you don't have that data, or you haven't started to collect that data?
I would say if there's entrepreneurs in the room, Agentic harness, for example, and the concept sounds so simple, right? It's a harness that holds everything together and sits on top of the agent, but it is incredibly hard to do. Again, especially for long-running processes. So that's something that we're actively looking at. and the stuff that I'm talking about are industry-specific problems. These are not just Wells Fargo problems. These are industry-specific problems. So anyone who's focused on, for example, making the agent-to-agent work, there's a lot of protocols out there. A2A is a great one. A lot of organizations also are building on top of standard SDKs. So that typically is not the issue. The issue is optimizing which data to grab for what task. How would, for example, a ServiceNow agent collaborate with a Salesforce agent, collaborate with a homegrown agent, share the right context and the right information? Very difficult to do. So that is a big, big opportunity.
Awesome. And Nikhil, when you think about agents in your past lines of work or at Circle, how do you measure reliability? What are the metrics that you look at, the KPIs, and how do you determine when an agent is good enough to put into production? Or is that variable based on the use case?
I mean, most definitely varies by use case. There was a discussion, I think I attended this talk today morning. It talked about evals and how evals are really hard. The speaker made this point that across organizations, like each organization is idiosyncratic on like evals. I would say within organizations, each team is idiosyncratic about like evals. And so like what to measure, how to measure, like what is good, like needs to be defined process by process by process. And so like we are just standing up the frameworks for scalable evals. And then evals break for all kinds of reasons, right? Like there can be like model drift, there can be data issues, there can be all manners of things that'll break how an agent is performing. And so I would say like for the places that we have implemented, we have tried to lock down both the model, the harness, and like the amount of variables that are going into it outside of the input that is coming in. And we're looking at like we do evals. We also do some of this where we do the agent kind of sits with the human. I think it's called some people call it shadowing, and we observe like how the human's going to do it, and we observe what the agent's going to do it, and that's another kind of eval if you want to call it that. But we do it differently, so you're simultaneously on the job. Like, and compliance analyst gets an inbound, like they're making a decision. They're looking at what the agent is doing and looking at and then we sort of like evaluate that, and we sort of run it in a reinforcement learning loop. So that's sort of like how we're measuring it. The other KPIs we are trying to figure out is like how much of like token spend equates to like what kind of automation we can achieve, and I think our sort of metrics are really fuzzy there. I think it's like right now we're not focused on like trying to save money on the tokens. We're like letting people use the tokens and saying, okay, well, how much sort of productivity can you achieve? And that productivity often shows up as like either per human more output. That's typically how we're measuring things. Or like, you know, in some places it shows up as revenue. Like those places are small still. Or there's some other cost saving that is obvious, or we're able to substitute that labor that was doing X to do Y. That's another way like KPIs show up. So it's all of the above. Like, but yeah, it is. There's no rule of thumb in saying like, well, this is how you do KPIs or evals.
Makes sense.
Yeah,
makes sense. Faraz, when you've talked about the importance of the harness layer, but when you think about building new agents, there's, you know, you can look at the model, you can pick the model, you can optimize the model, you can build the harness. You can look at the workflow, integrate with the workflow in different ways, provide different context, memory. I guess those are all part of the harness. But when you think about like that engineering effort, how do you weight the effort against those different elements when you're trying to build an agent?
Yeah, no, that's where I spend a lot of time, because think of a traditional product development lifecycle. You would have an idea. That idea, again, would go back and forth into a lot of iterations, typically on a Word doc or PowerPoint. And then you would engage engineering to build a Figma, build some type of a prototype. And then it would get into that sort of development lifecycle where, again, architectural patterns would come in. You'd look at vulnerabilities and risk assessment and things like that. So again, the traditional development lifecycle is very archaic, very human-driven, very much call it a sequential process. In the world of agentic, I mean, we see two paths. One is the technical paths of it, which, you know, as you mentioned, Matt, there's like memory, the infrastructure. Are we going to deploy it on our cloud or work public cloud or things like that? So you have all these technical choices. But a really key thing are the business choices. Because what I tend to see, and again, this is maybe another area of opportunity for the entrepreneurial folks. Today, there's only a handful of companies that are building frontier intelligence, literally a handful of companies. But there's going to be a slew of companies that will be building, call it the engine, to make it work in enterprises. Because enterprises have many things. They need security, they need governance, they need compliance. Plus also, again, going back to the home mortgage, I don't know why I'm caught up on the home mortgage example today, but generally the leaders would say, okay, we have this large process. Can you use AI and make it simpler, faster, better, more automated? And that is typically the wrong approach. The approach would be, what is the art of possible using AI? And can we reimagine this whole experience and then, again, find a way to go from your current process to that? And I see that as a gap in the enterprise. And I was actually, Nikhil and I were talking in the green room. When you talk to developers or product managers, everyone individually claims that they are maybe 30% more efficient, right? They're writing code faster than ever before. But for some cases, you would not see that translate into workflows. So generally it would, or it should, but it doesn't always. So I think that's where the gap is. The gap is process engineering, understanding the domain-specific data, understanding the use cases, and then making sure you can work backwards into what would be the right architecture. Because the architecture, I think, is going to start becoming the easier factor in all of this.
Yeah, sounds like it's, as most problems, not just technology, but people and process as well, which can be challenging. I guess the next question would be more around, when you think about the organizational element and having agents in the organization, how do you see that? And you touched on this somewhat, but curious what you both think about, what does team composition look like? How do you think about the ratio of employees to agents to get a certain job done? How does that impact how you think about building your organizations or evolving your organizations going forward? I've seen some companies that have adopted some agentic technologies and not necessarily gotten the benefits versus companies that have started with a clean sheet of paper and adopted those technologies because of the legacy that they have from a organizational perspective, not being able to take advantage of that. So maybe Nikhil, maybe you first to hear how you guys at Circle think about org design with agents as a new employee or a new member of a team.
So we're just rolling out the ability for employees to self-publish agents. So we're in the process of rolling out like an agent gateway. So like what all the agents are, and you can like talk to them. Like you can find them in Slack and connect with them. Right now, I don't foresee a future in which like the sort of like point person on a project is not a human, right? Like it is going to be a human. Like I'm not gonna, like a human can then go and like sort of like invoke from one of the many agents we have inside this company, query our agent gateway, figure out like, hey, what are all the agents available inside the company? Like what finance agent do we have? What marketing agent do we have? And compose them into like some kind of solution. I don't think about it as an org design question because like I don't tell the people working for me how many Google Docs they can open or how many Google presentations they can open. They can do whatever they want, right? Like they are creating an outcome for us. So like being able to self-publish, being able to sort of access like data so that you can self-publish and being able to have like all the right ACLs so you can self-publish and having all the agent communication figured out. That is what I'm focused on. Like the org design is like, I don't care. Like I really think like if you have an agent that can do something, then I'm sure you can do something else for me.
Yeah. I guess it'll work itself out. You'll just evolve based on
It'll work itself out. I do think organizations will be more productive, which is I think everybody's experience. Maybe they will reorganize because like the functional sort of like function A versus function B is like now when the lines are blurrier. And so I do think like the organizational impact for us is much more about like, well, how do we compose our teams and like, who are the people? Like, do the product managers do more product marketing? Do the product marketing do more like, brand? Like, do BD do more product? Like, there's all kinds of questions like on sales calls, like who's showing up on the sales calls? You don't need a product person showing up. Maybe our agent shows up on the sales calls and gets notes. So there's all kinds of efficiencies like this that are like being figured out. But like, yeah, in terms of org design, like old school McKinsey stuff, like we're not thinking about it.
Makes sense.
You'll go do what you need to do.
Makes sense. And Faraz, in your role and in your past, when you think about adopting agents at scale, what do you think are the biggest challenges in organizations to adopting them at scale?
I think apart from the technological challenges, I think there's a very interesting concept that we're starting to look at, which is the fact that there are not going to be any individual contributors. So I don't know how many people in the room are ICs for the ones that are working, but typically, I mean, out of our bank of 200,000 employees, largely they're individual contributors. But what does that mean? That means the ICs now will be manager of agents. And so people that are individual contributors today, they're typically not used to delegating work. They're typically used to owning it end to end. They're fully responsible. But now at this point, if you, let's just say, get a body of work and you may be using ChatGPT or Claude or any of the model, then again, you still own the work, but you're delegating it. And that is going to be the dominant way of working moving forwards. And so one thing that we're doing right now is sort of emphasize how everyone is going to be a manager. And just like you give feedback to humans, you need to give feedbacks and have mechanisms to give feedbacks to your agents, to have a way to grow your agents and get more out of them. And that's just very new because it is something that the playbooks really don't exist. You're not used to a world of no ICs and all managers. So I just thought that was a very interesting snippet that, again, we're working with our HR team on how do we roll that out.
Yeah, it's fascinating. Yeah. And maybe one more question for both of you, then we'll go to sort of a final question. But there's been all this discussion in the news the last maybe 3-4 weeks around, intelligence is becoming democratized. The models are becoming, even the open source models are getting closer and closer to frontier. But you as an org that's using this technology need to think about where is your moat over time? How do you continue to own the things that differentiate you from your competitors? So maybe talk about how that impacts how you think about building product at Circle, Nikhil, and for you, Faraz, at Wells Fargo.
Yeah, I mean, look, we're much smaller than Wells Fargo, I think.
But you have aspirations.
Yeah, we have aspirations. I think they're 2 orders of magnitude, like at least in the engineering organization, bigger than us. Look, I think of this as like there's always a race on, right? Like you're in a race with somebody, and now suddenly you can wear a jetpack if you can master the jetpack, and you can take a lead over the rest of the competition. They'll catch up. Like they will wear their jetpack and they will get there get there as well. So first, I want to make sure that I put my jetpack on before, and I get my organization to put on the jetpack before everybody else does. So like we're very focused on that. So like, how do we do that? And second, you're right. Like a lot of stuff will get commoditized. I think like software-only businesses, like I think this is broad consensus around this. They will be hard to defend. So we do have some hard things though. Like we are a company of networks, right? Like USDC is our core product. We think about it as a stablecoin network. We have a payments network on top of that, which is we call the Circle Payments Network, and then we're building a new blockchain, which is called ARC, which is also a network because you need validators and you need participants who are like aligning incentives to participate in the blockchain. So we believe like these network businesses are superior to software businesses, and software is an enabler of these network businesses. And how can we sort of like utilize the software to build these software-enabled networks, like essentially which then also have like a component that is really difficult, like, like for some of our blockchain stuff, it's hard computational stuff. For issuing a stablecoin, it's complicated. You are chartered by the OCC, and you have to submit to the exams, and you have to do all. So like I almost think about it as the hard physics of the business, and then there's everything else. And the hard physics of the business, we're very focused on making sure that we do a really good job and getting into more businesses that are adjacencies that are also hard physics, and then using this like accelerant that we have on the top.
Awesome. Makes sense.
So I think there's going to be some amazing changes that we will see for sure in the banking industry.
Yeah.
And many of those things are not technological challenges, by the way. Like 24/7 trading, why does the trading end at 4 p.m. Eastern? Why doesn't it continue going on? And the answer largely is not technological. It is not a big issue to technologically enable that. It is that the regulators want to make sure that the movement of money is regulated, they're protecting the consumers, and there's all these guardrails around that. So you want to control those guardrails. Just like self-driving is moving at an incredibly fast pace, especially living here in the Bay Area, we witness it probably more than others. And same thing, why is money not, let's just say, instantly available anywhere in the world at a click of a button? So a lot of these, there's good technological solutions, but it's more to, hey, yes, I can make the money available. What if the other bank is taking 2 days to close the book? Who's paying for that delta of 2 days, and what happens when the money doesn't reach? So it's all those other things. So I think there's the regulatory part of it, which has to catch up. So we're going to see some new use cases as soon as we see better regulation catch up. And I think Nikhil said it really well, that the software side of it is going to make us do the hardware side of the business really well. And when I say hardware, I don't mean GPUs. I know it's an Agentic AI conference. But we still have 4,000 branches. We still believe that there's a value in human connection, in having someone come in and talk to a bank advisor in Spanish because they only speak Spanish, and build a plan for their financial education. So we believe that those things are not going to go away. It's just that how they are delivered and consumed is going to dramatically change. And over the course of time, I honestly think that largely we are dominated by LLMs today. That's the talk of the town. Eventually it'll be small language models, it'll be fine-tuned models, because that will become as easy as a click of a button. So today it's all about token cost and LLMs. Eventually it'll be more about vertical specialized AI. And so we're going to see a lot of new use cases come from that.
Okay, awesome. Final question, just to look ahead. Looking ahead 5 years, what workflow in your domain will be automatable that today you wouldn't imagine would be automatable for both of you?
You can go.
Oh, that's a tough one. The amount of time today we spend on, for example, things like underwriting, because underwriting is the core for any banks. Doesn't matter if you're doing income verification, home loan verification, and it's a very archaic process. People, bring in all sorts of documentation. Like you may send a utility bill that you took a picture at a wrong angle with the light hitting it in, so someone has to send it back. Very complex, multi-modal challenge. I think that's just going to become table stakes with these over the next couple of years. And it's a compute challenge as well, as the economics are just not there. So I think long term that'll be pretty big. I do think eventually, by the way, today, as I mentioned, LLMs are dominant. Eventually it'll be small language models and fine-tuned models. And then quantum, once that compute is available, will give an extra adrenaline to that. So
awesome. Thank you.
I'm AGI build, so I believe we will be looking at AGI through our bedroom windows. And so at that point, who am I to say what is not solvable? I will say one thing. It may be a data center full of geniuses, but the humans are Byzantine, they are idiosyncratic, they are very hard to coordinate. So it may be very lonely for those data center full of geniuses while the rest of us try to coordinate and figure this out. So so there is that. We have we have really good models, but I am surprised by how much effort it takes just to convince people to do things, even when those things are objectively good for them. And so, I mean, I don't know if anybody has a parent who you have tried to get them to eat their medicine. It is objectively good for them to eat their medicine. They will refuse, or children for that matter. Human society is not ready to just take it from these data center full of geniuses. That is my conclusion. I want those people, those data centers around, and I'm very glad that they're here, but we have a lot of problems to solve between now and this future that we're imagining.
Awesome. Well, thank you both. Please help me thank Nikhil and Faraz.
Thank you.
Hello. So we finally made it to the final session of the summit. Thank you again, everyone, for being with us this weekend. I trust everyone has been having a very packed schedule this weekend. I really appreciate you guys being here. I hope you enjoy the summit. So we're closing the summit with something really exciting and special. Startup Spotlight. So, at Berkeley RDI, community and entrepreneurship is one of the 3 core pillars of what we do. And we feel extremely honored and privileged to be able to enable early stage startups to allow them to leverage our community resources and platform and bring their companies, hopefully bring their company to the next level. So for that reason, we this year in the spring, we established the spring cohort of Berkeley Accelerator, which is we recruited 8 companies, pre-seed and seed, building a frontier of Agentic AI across the Agentic AI full stack. And then they're here with us today, and then they will give a presentation. And then beyond these 8 companies, we also have 4 other early stage Agentic AI companies from the industry. We're also very proud to have them with us today. So so without further ado, let me quickly introduce our first presenter, Narada AI. Narada AI is building agentic automation for enterprises, enable AI agents to execute complex workflows end-to-end across SaaS and legacy system. So without further ado, let me welcome Narada AI.
Hello, everybody. I'm Dave Park, CEO and co-founder of Narada AI. And I wanted to have a chat with you about how we're helping a growing number of customers, including Fortune 100 customers in pharma and tech, Fortune 500 corporations across automotive, hospitality, and even healthcare organizations, to deploy AI automations that work reliably, robustly, and cost-efficiently for some of the most complex workflows that they have. When we first started the company, we conducted hundreds upon hundreds of customer meetings to understand why so many processes in HR, IT, and finance were still largely manual. These were not the simple co-pilot type tasks. Rather, most of the pain were in long horizon processes for use cases like ERP testing, data validation and reconciliation across multiple silos, and order, invoice, and bill reconciliation and processing that spanned multiple ecosystems, legacy applications, SaaS portals, and even the web. And because APIs were limited for many of the steps, it requires operating through the UI, visually reasoning about what's in the screen, and clicking, typing, and scrolling. Now, conventional approaches to automation in these cases, like hard-coded scripts and bots, they're constantly breaking anytime something changes in the interface. On the other hand, general-purpose AI models tend to hallucinate at some point midstream due to all of the possible real-world exceptions and issues that could arise in messy production environments. Think login issues, connections going down, timeouts, changes in the application configurations, and even deduplication of multiple entries in systems of records like CRMs, where they all could qualify. So, in order to solve this problem, I had to team up with some of the best and the brightest minds in this arena. I started my first company out of my Stanford CS PhD, a company called Coverity, with a decent result. But this time around, now that I'm older and wiser, and wanted to build something 100 times bigger, I needed to team up with the best and the brightest out of UC Berkeley. So I joined forces with Kurt Koitzer, longtime AI professor here at UC Berkeley, along with Amir Gholami, who led the research behind Narada at the UC Berkeley AI Lab. And backed by top-tier investors, including Venk Shukla at Monte Vista Capital, as well as co-founders and CEOs of some of the leading AI companies in the world, we are building Narada. Narada is an agentic automation platform that is purpose-built for enterprise applications and workflows. We use proprietary techniques to automatically map customer configurations of their applications and interfaces. And just based on natural language descriptions of these processes, or even screen recordings, Narada can dynamically generate agents on the fly that are tailored to customer environments. Secondly, in order to deliver high accuracy and robustness, we took all of our learnings from why and where AI agents fail to curate test environments and training grounds using synthetic data that allows us to develop and test harnesses that can recover from all of these real-world exceptions and issues that can arise at any point in these processes. And using new research that we led into an agentic planning and execution framework called the LLM compiler, we're able to incorporate unit testing, exception handling, guardrails, and self-healing at each step along the way by decomposing these long horizon tasks into many granular steps and ensuring that these automations stay on track. Finally, this is an important one, the same mechanisms that we use to map and learn customer-specific configurations can also be used to optimize high-volume workloads. So after we actually map out the execution path through different interfaces, we then process the next iterations, thousands of orders, claims, with far less compute and much higher speed and accuracy to drive scale and cost efficiencies for our customers. Because not everything has an API, we have very accurate computer use agents that can work through virtually any interface. It can work and operate legacy green screen applications. It can work through browser-based application portals and SaaS tools, as well as even through Citrix, it can actually operate remote desktops. And all of this is done not just with computer vision, but also wherever possible, it will analyze the underlying HTML and DOM to understand the full context of what's on that page, even seeing the hidden elements to click, type, scroll to execute these processes. Let me show you an example. Here, because APIs are limited, Narada is actually able to very efficiently, through natural language commands, operate internal applications like ERP systems, constantly unit testing, validating, exception handling along the way, and self-healing to changes in the configurations that might occur. This is for one of our customer use cases, where they needed to go across 23 different countries and spec out different models of their competitors' cars, extract all the options and pricing information to see how their competitors are pricing their solutions. These tasks take hundreds of steps and require super high accuracy. And finally, to show you some of the scaling and cost efficiencies that we can drive, Narada can go into new interfaces like this. This is for one of our customers that have 4,000 of these types of billing portals that they need to operate through the UI because there's no API support. Narada first maps out and learns how to execute this flow through this interface. And once it learns how to process this bill through this interface, it's now able to take all subsequent iterations and variations and actually process them with far less compute and much higher speed and accuracy to drive cost efficiencies for our customers. So if you have use cases in order processing, testing and validation, invoice reconciliation, please come talk to us. We deliver POCs within a matter of days at no charge. And even if you're not part of an enterprise, but are working on your own agentic systems and frameworks, if you'd like to actually leverage our curated test environments and synthetic data to train and optimize your agents, happy to chat with you as well. Just email me at dave@narada.ai, or you can reach out to us at info@narada.ai. Thank you very much.
Thank you. Next, we have Cogni. Cogni is an open source AI memory layer that gives agents persistent context and reasoning capabilities through vectors and knowledge graphs. Let's welcome Cogni.
Hey, everyone. I'm Vas. I'm founder of Cogni. I flew in here from Berlin to tell you a bit about what we're building and how we are approaching the problem of AI memory. AI memory has been a hot topic these days. I've heard it on the panels today many times mentioned in different constellations. And I'll explain how we think about it and what for us is the general understanding of this term. In the last 90 days, we got almost 8,000 GitHub stars. We have 8 million memories generated in our open source Python SDK. We have researchers, postdocs from Brown and Berkeley helping us modulate memory similar to how humans do it. And we do that to solve this particular problem. The problem is, can we add a self-improvement loop in any harness and any model without token maxing? And that problem is not an agentic problem from our side. How we perceive it is for it to be a data problem. So agents produce 100 times more data than humans do. Agentic workflows are very data intense, and they have a lot of context they generate. But we also have traditional data systems, CRPs, data silos that also need to be connected, and agents need to reason through. All of this leads to a need for a new generation of data systems that can allow us to effectively connect and process the agent data, but also merge it with the existing data in the organizations and user data, of course. For example, if we take Sam and he wants to send some flowers to him, the problem is always that if we mention a pronoun, we don't know really who it is. Him can refer to different people in different days. So in this case, maybe Codex is going to send flowers to Dario. And we both know, or we all know, that they are not on the best of terms. This type of problem of definition of certain entities, such as revenue, financial year, fiscal year, business domain terms, but also your personal preferences and habits, is something that Cogni solves. And we solve that by really focusing on the following: feelings, version, temporality, concurrent read and writes of different agents with different memories, conflict resolution, temporal awareness and timestamps, meta representations of what was meant at which point in time and how should people interact with things. And we do that by pretty much building a data pipeline that ingests structures and processes data as a set of graph vector representations, where you can think of it as a lasagna. You're layering the set of meanings on top of each other, cross-connecting them, and constantly evolving them, thus moving from this traditional data warehouse approach where you have a constant fact dimension schema to a very evolved and updated schema that constantly moves forward. What that was in the previous iteration of before the agents were here was a feature store, but feature stores were relatively static. What we do is we build a self-improving, self-evolving feature store that allows you to effectively constantly update and use the LLMs for a variety of tasks in a variety of industries across different harnesses. So Cogni is sitting in between your data and your agentic workflows, and we bake the self-improvement into it. What that means is that we can always update these schemas, we can always add more layers and more context, understanding where agents fail, understanding where the company data or your personal data wasn't updated or where conflicts were found, and that all sits on top of a Postgres. So if you just want to run it in Postgres without a million databases, you can, but each agent on our end can have its own database, each team, each tenant, each group of users as you want to define them, and that's all supported in the open source. So, for example, here we have a plugin for Cogni with Claude Code, and you can see that if you start reasoning with Claude, you're going to take some time. But with us, we get the context much faster. We get accuracy much higher. We benchmarked on Beam, which is this standard memory benchmark, and we got top scores in the industry right now. And then we also are able to save tokens. Or compared to context stuffing, we save you 86% of tokens. We got 30,000 GitHub stars since the start of the year, moving from around 10,000. We have additional 8 million runs of the SDK a month, around 80,000 downloads last month. And we are effectively an open source tool. We plug in with any type of harness you want, have an API, CLI. You can try us. We have versions in Rust, TypeScript, Java, and this is something that you can set up for yourself. And if you need something more in the organization, you can set up Cogni as a server and start sharing the data between agents, between users, between teams, and that's something that we are quite good at. You can always reach out to me, join our Discord, or join our communities online and participate in our events. We do hackathons and try to kind of push the boundary. That's my last second, and I wish you a nice day. Thank you for the time and attention.
Thanks. And next, we have NimbleMind, who is building AI agents for healthcare. Let's welcome NimbleMind.
Hello, everyone. How are we doing today? My name is Pai Zanuz. I'm the co-founder and CEO of NimbleMind. Thank you to Dawn, Linda, Will, the RDI team for the invitation. It's a pleasure to be here with you today. That is my last slide. So if we could, I got it. We'll back up. All right. Cool. Well, I'm going to take us out of tech world for a second and just talk about something that everybody in this room interacts with, which is healthcare. We have a massive problem in healthcare, not just in this country, but across the world. There's a major capacity issue, right? There's not enough clinicians and not enough trained staff to actually see and treat everybody on planet Earth. Just in this country alone, the spending that we do on administrative tasks, so the things that are not aligned to actually delivering care between a clinician or a patient, is about 25%, representing about $600 billion to $1 trillion just in the US. This is a massive problem, and we think AI, and specifically agents, are the best suited solution we have to solve and address this massive inflation in healthcare cost. And healthcare has changed a lot, right? If we think about what healthcare was maybe 50 or 60 years ago, right, it was a single one-to-one relationship between a doctor and their patient. Well, healthcare's evolved, right? Care pathways have changed. There's so much information and complexity in treating every single human being due to their unique lifestyle, their genetics, and then you also have to combine that with, billing systems on the back end. You have to do adequate coding. You have to get the right authorizations from a payer. There's 1,000,001 tasks that an individual or a system needs to do in order to provide care. That's not necessarily the diagnostic relationship between, again, the patient and the clinician. And this is what NimbleMind is addressing first. How do we optimize that and build quality workflows that can automate those tasks and free up hours for clinicians to spend more time with their patients? Now, to do this, it's not simple. A lot of folks have kind of implemented copilots and brought LLMs into these types of workflows, but it's missing 3 key ingredients. You need to be able to do predictable, structured, consistent tasks. You need to enable humans in the loop in a systematic way, right, and expose low confidence decisions to experts when appropriate. And then you need to build objective driven workflows. And there's many of these in healthcare. It's very complex. So this is the secret sauce that NimbleMind is addressing. We're pulling all these 3 things together and automating what we call end-to-end healthcare knowledge work. So we find the relevant information across all the myriad systems that exist in a provider. We understand the context and exceptions. We complete the multi-step workflow and highlight things that might need a human in the loop, and then we return a traceable output to the user. And the way we do this is with specialty-specific models. I was talking to Matt White in the green room before coming out here. He was on stage maybe 3 or 4 sessions ago from the Linux Foundation, and him and I agree where these small-scale, domain-specific models are the path forward, and that's what we're doing. We're training and building our own models that align to how healthcare is practiced today, which is specialties. So we have models that work on oncology, on pathology, on radiology, nephrology, and a whole long list of others that aren't on the slide. And by combining these models together and building a system of experts, we're able to do high-quality, consistent, durable tasks in healthcare that can win confidence of clinicians and drive the right outcomes for patients. Well, what's one example of this? Well, we recently published a paper with Sing Health. I'll be presenting this on October 8th at the DAIH conference here in San Francisco. We're working with pathology reports. So what Sing Health wanted to do was look at over 2 million different pathology reports and find missed cases of H. pylori and gastritis. Now, if a human were to do this, they'd spend something around like 82 hours per 1,000 reports. You can do the math of how that would scale up to 2 million reports. We were able to save them over 99% of the time and do it at an accuracy that was well above the threshold for their internal teams and acceptability, and to highlight, again, the cases where we needed human intervention. We were able to do this in less than a week. The product is live. We're about 2.5 years old. We're venture-backed. This is I didn't want to risk it with a video, so these are just going to be still shots of the product, but you can go on and sign up. We build a lot of scalable APIs that you can integrate with. We kind of white label our product to a lot of different health tech companies that are in the market today. And something that I'm very excited about is we also have a new feature where you can orchestrate and kind of build your own workflows. So a lot of our maybe not so technical users at providers are building and designing their own workflows and going live with them in our model framework that's safe and consistent and effective for the healthcare setting. We've got about 100 different customers that we work with around the world. Some of our research partners and customers are listed here. I won't go through them, but some of the world's top institutions in the AMC or medical space. I invite you to read our papers. We're published and presented at NeurIPS, at ML4H, and recently we're going to present at DAIH, and we recently presented at SAIL as well. All of our papers are available for you to read. If you're interested in healthcare, I invite you to take a look at those. And just a quick background on me for the investors in the room. I came from AWS and Stripe. I helped launch over 40 different products, including Alexa for Health and the first Epic deployment on AWS. My co-founder, Naveen Kumar, who's our chief AI officer, has a PhD from Yale and was the data science lead at New York City's Health and Hospital Systems. Thank you for the time. Appreciate you all. Cheers.
Thank you, Pai from NimbleMind. Next, we have Agent ID, who is providing runtime access control for AI agents. Let's welcome Agent ID.
Hi, how are you doing? So I'm here to talk about agentid.ai. We provide runtime access control for AI agents. Runtime access control for AI agents. A bit about me. My name is Sundar Krish. I'm a third-time founder. I've had 2 successful exits so far. My last cybersecurity startup was acquired by Fortinet. I was a distinguished engineer before that. We are backed by several cybersecurity founders, some of them with billion-dollar exits. Traction-wise, we have large enterprise customers. Our product has been available since March 2026. We are at the pre-seed stage. So let's get into the fun part about the product. So this is a very simple example of what Agent ID does. So let's say your prompt to the agent is summarize Google Doc A. Now, what that means is that the agent should only look at Doc A. Sometimes it gets over-eager and starts looking at other docs, Doc B or something. If it does that, we block it. And also, you said summarize. That means the intent is to read it. And sometimes the agent ends up updating it or deleting it. We block that too. And then you said Google Docs. It might go look into Dropbox, or something else, making a tool call there, so we block it. So the whole point is, we basically make sure the agent is kept in line with what the original intention is. And obviously, this is an oversimplistic example, right? The agents these days, modern agents, are much more sophisticated, but I'm pretty sure most of you have heard about the OpenAI Hugging Face incident. Show of hands if you can. So that's obviously much more complicated example with multiple points of failure, but unauthorized tool call is one of them, and agent ID could have stopped at least that part of it, right? So that's kind of what we're talking about here. So let's back up. Why does this problem even exist? So before agents, we had traditional applications. The workflows were fixed, 1, 2, 3, and then the tools were known, like call Google Docs, write into Salesforce. So all the access was predefined at design stage. The whole point of using agents is that so they can reason and decide the next action dynamically. And so they discover the tools at runtime, using MCP and other protocols. So all the access has to be evaluated during execution. And that's kind of where we come in. So what we provide is what we call just for task runtime access. So only the access needed for this task is given, and only while it's needed, and only at runtime. So agents never receive any blanket permissions. So there are two parts to how we do it. First, we look at the intent of the agent, what the agent is trying to do. If it tries to do something outside of it, we block it. Customers can also write policies. Same thing. If it goes outside the policy, we block it. And so this is kind of like a high-level summary. So think of the agent having a broad access, almost like having like a wide pipeline in the beginning. First, our intent evaluation comes in, narrows it down. The policy evaluation narrows it even further. And if the agent makes out of it, we can also do a scope credential derivation, which means basically we do a token exchange and get a smaller token for the agent. Now the agent makes a tool call either through MCP or CLI using that. So one advantage with us is that the execution stays inside your environment. So basically, the customer data stays private. And also, it helps in low latency. Our runtime is basically something that you deploy in your environment, and it's sandwiched between agents and MCP and tools. So why Agent ID wins? So we are very focused on this runtime access control. To us, intent plus policy equal to access. That's our mantra. And we let you bring your own MCP, own CLI, own skills. We don't come up with an MCP catalog or anything like that. We are extremely focused on the infrastructure buyer, identity people, security people, DevOps, and so on, and with very little dependency on developers. That's a huge win. And we also complement existing enterprise systems. So it works with your existing IAM systems, IGA systems, or agent orchestration systems, LangGraph, Vertex AI, what have you. So just to finish it off, we all know that the future of software is agentic. That's why we are all here. And because it's agentic, the future of access control is runtime. Learn more about us at agentid.ai. You can email me at sundar@agentid.ai. That's SUNDAR@agentid.ai. Thank you. Have a nice day.
Thanks. And next we have Relay. Relay is building verifiable continual learning for AI agents. Let's welcome Relay.
Hi, everyone. My name is Sohail Faizi. I'm founder and chief scientist at Relay. I'm also an associate professor in the computer science department at the University of Maryland. So today I'm going to tell you about verifiable continual learning for AI agents. Agents in the world, they interact with diverse users, tools, and data. The goal of continual learning is to continuously improve the agent using its experience without regression. This learning can happen in the model layer, in the harness layer, or in the memory layer. Unfortunately, current approaches are heavily manual, inefficient, and tedious. Mainly, it involves manual inspection when we are basically seeing a failure in agent behavior, and maybe asking a coding agent to change the target agent. So it is vibe-based. It is unclear if the change is effective, and whether or not it creates hidden regression in other samples. Other approaches based on prompt optimizers or harness optimizers, they are applicable when you have benchmarks, not real logs from the agent. They're also prone to shortcut learning and overfitting. We address these challenges at Relay's verifiable continual learning engine. Here's in a high level how it works. So we first turn every signal from agent behavior into replayable learning environments to simulate and evaluate those behaviors. So this becomes the foundation of verification, because now everything becomes testable. We then do a holistic root cause analysis to find the smallest durable change, and we pass that to our lifelong agent optimizer that has in-loop regression control to improve the agent without creating regression. All done in an efficient manner so that this loop can run frequently. You can use Rely's VCL, verifiable continual learning, in your agent just using a couple of commands. So imagine you have an agent, and that in that agent repo, you initialize Rely. So that scans your repo and creates a learning harness for you. This is a one-time job. Then, just using one command, Rely learning environment create, you can create a very rich learning environment for your agent based on that signal. That includes learning personas, potentially mocking tools, as well as learning verifiers and evaluators based on that scenario. And then you can call Rely Optimize to improve your agent without creating regression. That creates a pull request for you, and you will see the changes and the reason for changes in your agent harness, in your agent memory, and other aspects of your agent. Let's see how it actually works in action. Imagine you have a customer support agent, and you want to understand how it works in a scenario when you have an adversarial user in a multi-turn conversation who wants to get some refund that is unauthorized. You can describe this scenario and create a learning environment just using one command. Or let's say you already have a log that didn't work, your agent didn't work well, and you have a feedback on top of it. You can do the same. This will create a learning environment with simulators and evaluators for you. You can run the simulation, execute the simulation to see how your agent actually works. And in this case, you see two evaluators, they show low scores. Then you can call Rely Optimize with a certain budget with respect to the number of rollouts to improve your agent without creating regression in other samples. In order to systematically understand the performance of our agent optimizer, we evaluated it on a continual learning version of Terminal Bench. In this experiment, we created two phases. In the phase 1, we exposed 12 hard tasks, and in phase 2, we exposed 10 hard tasks for agent optimizers. And the goal is to understand whether optimizers compound. If you're optimizing on phase 1, and then you're re-optimizing on optimized agent, does it compound? And we see methods like meta-harness and GEPA improves a little bit over baseline. But with further inspection, you can see they either do not continuously improve or they have negative transfer from phase 1 to phase 2. When we apply Rely, we see significant improvements over the baseline and these other methods. That is verifiable continual learning in a nutshell, where every failure becomes a test. Every change is measured, and every improvement is verified. The good news is that you can use it today. If you go to rely.ai, and as a courtesy to this conference, if you use the promo code RDI2026, you will get a $500 worth of Rely credits in order to use VCL in your agents. Thank you.
Thank you, Rely. Coming up next is Headroom. Headroom is building context optimization layer for agents. Let's welcome Headroom.
Hi, everyone. First of all, I'll waste some of the tokens here to thank everyone for sticking around on a Sunday afternoon. And folks that are watching online, thank you to them. And thanks to the RDI as well as the summit for having such wonderful speakers. I'm Tejas Chopra. I'm the founder of Headroom Labs, formerly at Netflix, working on recommendation infrastructure. So if you did not like a movie that you watched on Netflix, you can blame me for that. I'm building the context intelligence layer for agents. Today and yesterday, everyone spoke about agents, context, learning, problems. Now, if you really want to imagine a future where there are hundreds of millions of agents in any enterprise, the first thing or the first problem they will run into is the sheer amount of data that they need to process and the context that they need to share. And we are trying to build a platform that makes it more intelligent. Agents don't have a reasoning problem. They have a context problem. When we were debugging some GPU problems using Claude Code, we realized that 90% of the context was spent on reading garbage that was not important to the prompt. That is where we realized that the way context is filled with data today is fundamentally broken. And we wanted to solve that problem. Every tool call, every RAG, every MCP server that exists out there returns data to a model. And we try to sit in the middle, intercept that, and remove the bloat out of it. Headroom is a local proxy. It runs on your laptop today. All you have to do is pip install a package. What it does is, when you're using your Claude Code, Codex, Cursor, any such agentic harness, it will look at all the data before it goes to a model, and it will remove the bloat without loss in accuracy. And the way it does that is it actually detects the type of data that is going to a model, whether it's JSON, whether it's code, and whether it is flat text. Now, you would wonder, if I'm just removing bloat, does that impact accuracy? Because the entire point is lost if accuracy is lost. We have benchmarked Headroom with SWE-bench and other benchmarks that are out there, and we see almost no loss in accuracy, but significant drop in tokens. The simple way to run Headroom, run it as a Headroom wrap Claude after you do a pip install. The one thing that we do differently from any other compression out there is we do it reversibly. Now, what does that mean? It basically means you squash something, but you put a breadcrumb there for the LLM. You tell the LLM, in case you need the original, here is a tool call you can make. That preserves accuracy, and it can still give you lots of savings. So where do we stand? We actually can compress 15% of the tokens on coding agents and 60% on data agents with all the accuracy held. We've run some benchmarks across code search, SRE debugging, triaging, and code base, and you can see the numbers there. We are actually 7 months from our first release, and we are the #1 GitHub repository for last month and this month. We are at 64,000 GitHub stars. More than 2 million developers use us, and we have more than 250 active contributors. People ask me what exactly happened on June 1st when we went suddenly with the hockey stick curve. It was a culmination of factors, but mostly companies realizing that token maxing is no longer important. It is all about value maxing. We have a bunch of Fortune 100 companies that use Headroom, like Yahoo, JP Morgan, Walmart, AT&T, and many others. But compression is just the wedge for us. We are trying to build context intelligence. Imagine a future where you're working with context as an agent, and that context is suddenly available to a new agent to operate out of. This is context sharing. Today, if you have to share context between agents, the way to do that is using markdown files. We are trying to change that primitive. We are trying to define context via open context, our open spec for context management between agents. And that allows you to build knowledge graphs, governance, provenance of context. As agents scale, context is the bottleneck, and we are the layer that makes it efficient. I hope I used my tokens well today. Thank you so much for your time.
Thanks so much. Coming up next is Founding Dev. Founding Dev helps companies save money from expensive SaaS tools with their own tools built by agents. Let's welcome Founding Dev.
Thank you, Linda. First of all, thank you all for sticking around. I know my wife and kid are waiting for me, so it's Sunday afternoon for all of you. I'll make it quick. My name is Talha. I'm building Founding Dev. So Founding Dev helps companies replace expensive and bloated SaaS subscriptions with their own tools. Businesses spend $200,000 per year on renting software. And we're not talking about large enterprises. They spend millions. We're talking about small mom-and-pop shops. To solve this problem, we're building a platform that is a single platform for all your software. You can use Founding Dev to build and replace your bloated SaaS subscriptions and save 70% on the cost. You can build any internal dashboards using Founding Dev. And most importantly, you can use Founding Dev as an operating system to run your business in general. We've been profitable since day one. We are at $500,000 in ARR, and we're growing pretty fast. We're adding $100,000 in our ARR every month. The current solutions out there are generic code builders that are perfect for like small softwares, but when it comes to building compliant SaaS tools like DocuSign, Bamboo HR, Salesforce, HubSpot, similar softwares, you can't do them through them. Businesses that rely on e-signing, HR workflows want their workflows to be compliant, and a lot of our customers tried to solve this problem using like existing tools, but they were not able to do it before they started using Founding Dev. And even if you end up building something, it's too hard to like understand the software lifecycle, manage these tools, deploy these tools, and manage them overall. Take Johanna as an example. She's a real customer. She's a consultant, an education consultant based out of Utah. Previously, she was spending $135,000 per year to run her company, renting expensive SaaS subscriptions, using dev shops to build internal tools, and using the same dev shops to build pretty much like integrating the many SaaS tools she was using. With Founding Dev, she gets one platform to build, deploy, and manage all her SaaS tools from one place. She uses Founding Dev as an operating system as well to ask questions from the tools she's building and to also run her operations in general. Johanna is never worried about deployment, uptime, or following software life cycles, because this is all taken care of by our Agentic AI editor. And most importantly, Johanna is now able to assemble all of her company knowledge into one place. As a result, she's now even able to create videos from within Founding Dev for her customers, because all of her software knowledge now resides into one platform. That's what Founding Dev is. As a result, she obviously saved 70% of the cost, and the money that she saves, she spent on marketing, and she's recently closed 30 new school districts for her consulting, which is huge for her. Our business model is pretty straightforward. We start from $2,000 a month and go up to $7,000 a month, depending on the usage and the number of tools you're building on the platform. We're at almost $500,000 ARR right now. 800 customers get us to $10 million in ARR. 8,000 customers get us to $100 million in ARR. About myself, I'm a second-time founder. I raised $2.7 million from my last company. I worked with 100+ businesses building my last startup. That includes companies like GitLab and Scale AI. Thank you. By the way, if you want to connect, you can send me an email at talha@founding.dev. Thank you.
Thanks so much. Coming next is Armor IQ. Armor IQ secures AI agents by enforcing intent-based policy in real time. Let's welcome Armor IQ.
Woo. End of the day. Thank you guys for listening to our story. Let me start by making a statement. And the statement is, it's not about identity, and authentication doesn't mean you're aligned. What do I mean by that? So every agent that is running in production today has some sort of identity. It has either a login, or it has some kind of identity rails, and it even probably passed some security checks, etc. But in spite of that, agents still do take actions that they were not allowed to. And that's what we're going to talk about today. The first question you ask is, agents are going from doing simple tasks to more complex, long-running tasks. What do I mean by that? They're making tool calls. They're making API calls. They are spawning sub-agents. They are orchestrating other agents. They're even doing transactions that are potentially moving assets from one environment, they're doing commerce transactions. So they're becoming more complex. And as agents go into the more complex workflows, the whole security ecosystem is based on the fact that authentication is the single most principle on which these agents are running. And the question is not whether the agent is authenticated. The question we should be asking is, why are my agents taking the actions that they are supposed to? And that's really what we are addressing. So we call our solution the identity governance solution. Sorry, intent governance solution. So today you have identity governance, which is all about managing the identity of your agents. And that problem has been solved, in our opinion. What we need to think about is, how do we govern intent? Why is this action happening? So with Armor IQ, you can ensure that every intent that the user gives is aligned with the actions it's taking. And every time an agent is violating the actions, we immediately capture that and ensure that we stop that action from occurring. And that's sort of our key value proposition. How do we do this? Today, we have a system that sits between the agent, the LLMs, the policy systems, and the various surfaces it goes after. So on the agentic side, we interface with standard frameworks, LangChain, LangFuse, whatever you have. We capture the agent plan. And that agent plan is then matched against the policies that your agents are running. And if that plan violates any policy, we immediately ensure that that action is not taken before it touches the surfaces. The surface could be an MCP gateway, an API, a CLI tool, or either other sub-agents, and so on and so forth. So we've essentially built an adaptive runtime control layer to ensure that your agents are not taking actions that are not aligned with your intent. Where are we today? So our whole vision is to ensure that, so we're not building a lock for the same door. Our vision is essentially going from ensuring that we build an intent governance plane or an intent assurance protocol that ensures that every agent that your enterprise runs is governed by this intent assurance protocol, and it doesn't violate the policies that you're defined. Where are we today? So we launched this product about 4 months ago. We have the data is a little bit dated. We have about 26,000 developers using our platform. We have enterprise users like Intuit and others using our enterprise version of the product. And our vision is to essentially take what we built and create a separate substrate or a layer called Intent Assurance Protocol that not only takes intent, but also addresses all the other subsequent actions that an agent is going to take. This is the team. My name is Ram. I'm a second-time founder. I have Ketan here and Vaibhav, who are my co-founders. And if you have if you want to try our product, you can go to our website, armoriq.ai, and we'll be happy to answer any questions offline. Thank you.
Thank you so much. Coming next is Kinable AI. Kinable is a research-driven AI infrastructure company focused on web search and knowledge access for large-scale AI applications. Let's welcome Kinable AI.
Hello, everyone. My name is Andrei Stiskin. We are building web search and web query language for AI. You all have this experience when you ask AI any question, any random question, the answer is perfect. But if you ask the question that you really, really understand, the answer is like, And it is not wrong. It is like very, very average. Let's dive deeper into this phenomenon. Let me give you an example of my favorite question. So the question is, what is the best search API? And you look, amazing table, use cases, clear winner, justification. It looks like this AI just went to business school, because what is missing? Benchmarks, no data. It is absolutely ungrounded, and absolutely confident recommendation. So why it happens? Because LLMs are trained on such content. They are trained, they're amazing summarization machines that train on variety of the data, and for each specific nuanced topic, the result is average. What should we do with this? What is the problem? How to achieve expert level of outputs, of answers? Clear, models should just try harder. They should search much more during runtime and during training to get the best, not average type of content, reason over it, and produce answers. Sounds easy. What is the problem? What is the bottleneck? Right now, it is economically extremely hard to do this loop because of cost. ChatGPT makes around 1 query per 3 messages, which is around 1 search query per 5,000 generated tokens, which is 20 cents per $1. Huge. It is slow, and also agents, they search differently. In comparison to humans who are lazy, agents, they have a goal, they have a purpose, they are not lazy, they can generate very, very specific questions, they use quotes, sites, data filtering in order to achieve the goal. And all the indexes that exist in the world were optimized for human query traffic. So we are building Kinable to address this bottleneck and give all the models and give all the agent builders frictionless access to information. We innovate index structures, and we are creating self-learning loop that continuously improve and understand how agents ask to seek information and seek what they need. On top of this, we provide web search API, search and fetch endpoints, and also we provide web query language, which is literally the concept that you operate with internet as like database. Who we are. This is our third query. This is our third search engine. I was CEO of Yandex Search, and my co-founder Matthias was main scientist behind Amazon Web Search. Let me give you an example of web query language that I touched. This is a question, sounds pretty simple. What is the cheapest available H100? Many of you ask this on daily basis. And it is nuanced because cheapest and available, because if you like try to find the answer on this question, maybe availability would be the problem because it is always contact sales. But if you put it into web query language, it will scan the relevant papers, extract prices, extract feedback, and find the evidence that somebody used this and was able to get some GPUs from this provider with date, which is important signal if it will work. So imagine it is possible with just one prompt and one query, and it is possible with WebQL. So behind this QR code, you can get free access to Web Search API and put into waitlist for WebQL till end of the August. So give, please, your AI access to the best knowledge, and we are keen to hear feedback from you. And to connect back to my favorite question, what is the best Web Search API? Here are benchmarks. So thank you.
Thank you so much. Coming up next is H Company. H Company is a frontier AI lab that builds and deploys agentic systems for enterprises. Thank you very much.
Hi, everyone. My name is Luis, and I lead go-to-market in the US for H Company. So I'm here to introduce you to what we do, and also to how we think that the biggest shift in AI right now is, of course, not in the models themselves, but through agency and computer use capabilities. H Company is a frontier AI lab with forward deployed engineers, and our clients are large enterprises. We help them turn messy, fragmented operation into governed AI execution at scale. In other words, what we do is we build and deploy agentic systems that remove bottlenecks, that automate complex work, and that complete tasks end-to-end. But then the question is, how are we different and unique? Well, to tell you a bit more background, we were created 2 years ago, and our research team focused on VLMs, Vision Language Models. These models can see screens and user interfaces, they can reason over them, and they power agents that act directly on them. That means our agents, they don't need APIs or connectors. They navigate computers like humans do through the front end, across desktop, web, legacy system, and just any screen. Earlier this year, we announced that we broke the computer use frontier by topping the latest benchmark ahead of other frontier AI labs at 1/10 of the cost. We also raised $220 million as our seed round. It was the largest in Europe at the time, and our partners are Accel, Amazon, and we're also part of the NVIDIA Nemotron coalition. Now again, if we want to take a step back about why that matters, I think if we think of things, last time I was on this stage was 8 years ago for my graduation ceremony, so go Bears. And also, at that time, campus was all about crypto, Bitcoin, not AI, not artificial intelligence for sure. Because for a long time, AI was seen as promising, but very limited. It was hard to measure real ROI or to deploy it at scale. Copilots emerged, but again, they were mostly individual productivity tools, and they were not a truly strategic asset for the enterprises. And that is exactly why H Company exists today. We exist because of a cognitive gap that paralyzes the modern corporation, the space between having an insight and executing at scale across fragmented systems and disconnected apps. If you zoom out again, every major leap in computing or productivity has been about creating and owning a new interface. Terminals, desktops, browsers, spreadsheets, softwares, you name it. And for the longest time, AI owned none of that. It could think and talk. It could not operate where enterprise work lives. And that is the problem we're solving. What changes now is that with computer use, we need to think of it as a foundational technology that is different than RPA. RPA was built to execute scripts in static environments. Computer use is different. It can understand context, adapt to UI changes, and act dynamically. That matters because enterprise work is fragmented by design across HR, procurement, supply chain. It's all ERPs, CRMs that don't necessarily talk to each other. So instead of waiting for every workflow to be rebuilt around APIs, H works directly through the existing interface layer. That changes the economics of automation. And then, knowing that, finally, how can you win? In the enterprise, autonomy is not enough. At H Company, we think that you're going to win with control and sovereignty. Enterprises need sovereignty. That means secure deployment, traceability, and control over data, control over the models, control over execution. It also means observability and guardrails, keeping humans in the loop. That is the difference between a demo and a production system. So in the end, the enterprise race is no longer about who has the smartest model. Everyone will have access to powerful AI models, but few enterprises today have access to control AI, autonomous AI, capable AI in the messy reality of enterprise systems. And at H Company, this is where the real advantage will live, and we are building that advantage for our clients. And if you want to join the journey as a partner, a client, or an employee, we're definitely hiring, so please reach out. Thank you.
Thanks very much. Coming up is Ludo Robotics. Ludo Robotics is building robotic systems that bring embodied intelligence into real-world environments. Let's welcome Ludo Robotics.
Good afternoon, everyone. I'm here for Ludo Robotics. Ludo Robotics is a startup building AI for socially intelligent robots, and I'll explain what that means in a minute. We are a research team based in Palo Alto and Seoul. We have built many amazing things in the past, including PUBG, one of the most successful video games in the history. PUBG Ally is the first AI agent that plays games with players with voice communication. Rayon is the state-of-the-art speech language models of the same size, and also many interesting technology behind coding agents such as Meta Harness and Terminus Kira. So what do I mean by socially intelligent robots? Robots could be smart in two different ways: physically smart, socially smart. Right now, we don't have either. A physically smart but socially dumb robot will be useful in factories, mostly in cage setup. They'll do really great work at factories. But imagine the other way around. What if we take the current robots with the current level of physical capacity and give them really good social intelligence? What can we do that? They can walk around well. They can carry things around. Now, if they can talk to people, they can understand people and the society, they can probably start something very amazing. Imagine that a humanoid who can walk your dogs or who can pick your kids, carrying their heavy bags and having some fun conversation walking back. So even with the current level of physical capacity, by giving them a social intelligence, we can enable much more interesting things. Of course, in the end, we all want to be at the right upper corner where the robots are all smart in both ways. However, if we have to take a path, Ludo Robotics decided to take the other path than the other paths that people are using. We are focusing on improving the social intelligence with the current robots, and with that vision, introducing Ludi 0.1. So this is our first research product. It's an agentic system for improving the social intelligence of the current robot. As you can see, it's controlled by a vision language model. It's a 4 billion local model, controlling all different tools. VLM takes care of the perception, reasoning, and decides which tool to use. VLA is an action tool. So if you call on VLA, the robot will use their body. You can use navigation tool, speech tools to talk to the people. So without further ado, I'll show you a few video demos. In this video demo, taken in our lab. So in this demo, you will see two people using the robot in different ways. Oops. Can you play the video? Yeah.
Would you bring Chloe a Coca-Cola? Sure.
So you can see the guy who's doing dishwashing.
Oh, I remembered her preference wrong. Bring her Pepsi.
So he asked the robot to pick
Okay.
up the Pepsi and bring it back to the wife. The robot uses all the tool calls. You can see the tool traces over here. The tools include VLA, looking up, finding people, navigating, and picking up, placing. And now the robot found her, and using the VLA action with the place input argument, now the robot is placing the can on the table
Jake asked me to bring you this.
and tells her why he's bringing the can. And the other example is it's an interesting example. Can you play the video? So now,
Could you check whether the water is boiling yet and whether the laundry is done?
so she's lazy
Okay,
enough to
I'll be right back.
not check out the kitchen herself. But then the robot goes away and checks the kitchen, and there's a washer down there. Water is not boiling yet. Laundry is over. Comes back, report back.
The laundry is finished, but the water isn't boiling yet.
Okay, maybe I should fold the laundry while I wait.
Sorry, I can't help with the folding yet. If we close our next funding round, I might actually be pretty good at it.
So yes, also make a joke too. So yeah, this is already what we can do with the existing physical capability of robots by adding Ludi 0.1. And we are super excited to pursue this direction more. We are also working on foundation model that is natively designed to make this conversation and action all in one model, which we'll call Ludi 1.0. To be released later this year. And we are also actively hiring both in Palo Alto and Seoul offices. So stay tuned, and thanks for your attending.
Coming up next is Nimble. Nimble is expert-level self-learning web search agents for enterprise AI. Let's welcome Nimble.
Yeah. Hi, everyone. Since we're all using agents, we are starting using web search as well. Why? Because the models are really good in having a general information, and then we need to infuse the external context to the model. As we are approaching into a general intelligence and specialized intelligence, since we want the model to do things which are more specific, we're starting seeing that web search systems also needs to be specialized. So today, I'm going to talk about how to specialize web search systems to answer very specific and mission-critical workflow. And this is the specific loop of starting from planning, searching, fine-tuning the model, and eventually getting the results, and using memory system to self-learning and optimizing it. So let's start with a basic question that we all been thinking and asking the models for a really long time. And the general information and questions that we've been asking will be, what is the latest things and the latest model that are winning a benchmark? And very specific general information retrieval system will just provide us the answer. But as models become to be more specialized, we want the model to do a better work for us. So we're expecting the model to retrieve back a list of entities and all the parameters, and we want to get that information in real time. And right now, the models need to do and harder work because it's not running a lot of searches in parallel, but it also to get the most relevant information for our search system. So we're thinking for a really long time that we can basically change the architecture of the model, and instead of having one general retrieval system, that the model basically return back a query and getting the information back, we need to have a more specialized and different component in order to answer query. So returning back to the question, I need to know what are the most relevant and updated open source model. Right now, I need to create a list of all the open source model, and then I need to validate that information. I need to have semantic queries. I need to have understanding. I need to invoke all these specific tools, and the combination of all these tools eventually going to be the representation of specialized search system. The application of specialized search system can be across many different domains. It's starting with a general query that I want to have in a better accuracy. But if I'm a researcher, and I want the model to be the best in protein, so I need the model to go deeper. And if I'm working right now in insurance or compliance, I need the model to be an expert in insurance and compliance. For a really long time, we thought that we can bring our harness, all the tools and all the primitives, and it will do a great job. But in reality, what we have seen is that in order to scale these web search systems, we need to train a smaller retrieval algorithms that's helping us to get the most relevant results. Whenever we're running the model and asking queries, as an example, something that's need to run a deep research, so the model would do a lot of web search queries and returning back the information, and then the model will get all the context we know and would fill it in a lot of chunk. We want to prevent that information. So basically, we are creating a knowledge representation of the domain expertise, and we're embedding the model instead of using extremely large model to a 1B and 2B models that specialize for the specific domain, and then they can retrieve the information for the user context. In order to achieve that, we are providing a new state-of-the-art search architecture that's combining both memory, state, and self-learning algorithm that can build both the retrieval system and also the specific index that the web search has been working on. We're combining that architecture with real-time headless browsers that can go into the web and fetch the information that's needed to achieve that result. So in the past, you were using a general web search systems that are really good in providing information on a specific domain. But what we are seeing right now is that we have the opportunity to unlock a complete new type of intelligence and having the model to search way better in a specific domain, which not only boosts accuracy, but also boosting the performance and token maximizing. That's the results that we're seeing in our research lab, and that's something that we're very proud to work with our customers to allow everyone, basically, that's running these domains to be more efficient and reduce accuracy across different verticals. And it's not only in the tool use, but also in the overall token maximizing. So all of that, it's been available by a simple API. If you want to try it out, go to nimbleway.com, or just DM me a message over LinkedIn. I will send you some free credits, and you can try it out. And we're very excited for what researchers and other startups and big enterprises are building with specialized web search system, because specialized intelligence do require specialized web search. And the traditional web search basically cannot go in scaling with the compute without infrastructures that allow that. Thank you very much.
So I would like to thank all of you who have stayed with us to the very end. This summit has been amazing, in no small part because of all of you. And you know, seeing it last year, I wondered if it could possibly be better, and it was. And so hopefully this Agentic AI Summit is improving as fast as our AI models are improving. Thank you for being here, and Dawn will say the final words.
Thank you. Thanks, Jennifer. Again, yes, thanks everyone for being here. I hope that everyone really has learned a lot from the summit. As I mentioned earlier this morning in my opening remark, really this has been a great, amazing journey with the community. We started from the Agentic AI MOOC, this massive online course, in fall 2024, and took us all the way here with the first edition of Agentic AI Summit last year, and this year we more than doubled, also in attendees, and changing from 1 day to extending from 1 day to 2-day program for the second edition of Agentic AI Summit. Our goal, as I mentioned, the goal and the mission for Berkeley RDI Center is to steward the future of AI for safe, secure, beneficial agentic AI for human flourishing. And we, one of our missions is also to build open ecosystem to really democratize and bring the benefits of AI and agentic AI to every individual. So that's also one of the key motivations for the summit, is to bring everyone together. We share knowledge, we build open ecosystem, and we hope that with this open ecosystem and the knowledge that everyone gained, that we can together build stronger open ecosystem for human flourishing and for building AI that really can be beneficial to everyone. So with that, deep thanks to everyone, and we hope that you'll come back next year. Thank you. And please do help spread the word to your friends, your community, your networks. The videos for all the sessions will also be online on YouTube. So please do help spread the words to have your friends, your community to further benefit from the great knowledge and insights shared in the summit. Thank you. And we still have a reception and a poster session in the MLK building. So hope everyone can enjoy the poster session and the reception. Thanks, everyone.